we create for you for today awesome speech and awesome, I think, flow. What will we do? And before we start, I want to first of all say that my name is Artur, and I will be host today for you. And today with me, Marina. So let's say hi for her. Yeah.
Thank you, Artur, for introduction. And I hope it will be fine for now. Well, thank you, dear guest, for joining us today. And let me invite on the stage our special guest. First of all, Dr. Mr. Clarke, the first Deputy Rector of VIUT. Welcome. And Renat Akhtyamov, General Director of EPAM Systems.
Assalamu alaikum. Good morning, everybody. All IT professionals, IT community, IT students, and those without a tie. Yeah, so welcome today, by the way, to this Rolling Scopes conference today. So it's a conference which will look at IT developments in the field, and we'll also look at major organizations like Amazon today, and upbrief you on JavaScript as well. The second thing is also important. It's about getting to know each other, because there's a lot of network that's going to go on today. And it might be for some people in the room to get jobs, to secure internships in the IT world as well. So it'll be a great day today, and I wanted to, on our university, because we do offer IT courses as well as IT degrees. It's a great way for our students also to benefit as well. But you're all very young in this room, and I'm probably the oldest one in this room here today. Back in 1984, I had a Sinclair and a Commodore 64. Does anybody remember that? Some people do, probably this guy at the very back. But I used to program basically with a massive big TV. And I was gearing myself up. I didn't actually take IT. I was actually taking business studies at the time, so I'm actually self-taught. And I was programming the size of this building, mainframes. Nowadays, it's on your phone. It's actually bigger memory than a mainframe that would have been the size of this particular building. But it's actually incredible in my journey, but I couldn't even switch on a computer today. So I've actually went full swing, just to let you know. So full swing in the way. But at that stage, I was probably logical in the left brain, and I've actually moved to the right brain in terms of being creative. But IT is not about being logic today, because a lot of people in this room are left-brained and right-brained. So you're very creative, you're coming up with different apps and things which will obviously be for the future. So this is a conference really about the IT developments today. And I wanted to pass on to my colleague, from our director from EPAM, who's we're working in partnership here today. And I'm sure we're going to basically have a lot more different activity throughout the years to come. So have a great conference today. As you leave this conference today, take one or two things away with you, which will make a difference. And that way, that this conference will be of great benefit to you. So have a great conference today. Rapmat.
Thank you. So, hello guys. My name is Renat. I'm the head of EPAM Uzbekistan, and I'm really glad to be part of your conference today. Some of you may ask a question, what is the connection between Rolling Scopes and EPAM? So Rolling Scopes is the external community, totally independent community from EPAM, but 9 or 10 years ago, this community was launched by EPAMer. He's here today. You will see him right after me. And it was founded in Belarus, but spread to any other countries. And 3 years we have this community in Uzbekistan. And 3 years ago, EPAM launched delivery office in Uzbekistan. We started from the 5 people, Java engineers on board, and were thinking about how to drive the market, how to develop a market, how to involve many young people to become an IT engineer. And then we found inside EPAM people who were driving Rolling Scopes community, and I really liked the principles. It's the first principle: full materials are open source. They are available on GitHub and YouTube channels. And the second principle is teach it forward. It means that if you pass the education in Rolling Scopes school, you can become a mentor to share your knowledge with the next generation of students. And twice per year, Rolling Scopes run the educational program to teach people. And many of Rolling Scopes graduates join EPAM. For example, many of our current leaders, core team who organize this event, they are from Rolling Scopes and they are EPAMers right now. Okay, I'm really happy that we are close to 300 people. As I know, the total quantity of, total headcount of community is close to 1,000. And after 3 years of being here, EPAM is also close to 1,000 engineers on board. And we want to speed up this development, and we really need your support, guys. Please join our community, to become a mentor. It's really a good thing. And if in Tashkent we have enough people, we see the big problem in regions, and I encourage you to spread this community to the regions as well. Okay, again, thank you guys. Please enjoy meet new people, enjoy this great event. Thank you.
Okay, thank you very much, Renat and Mike. So we can, actually we're not done with welcome speech. Am I correct, Marina?
Yes, we would like to invite another special guest. The first one is Dmitry Varabei. He is actually the founder of Rolling Scope School, and also I would like to invite on the stage the chief coordinator of the RS school in Uzbekistan, Zafarbek Khodjaev.
Thank you, guys. Thank you.
We need one moment. Where is internet? I'm sorry, but да, сейчас. Я специально. Подождите. Потом презентовать. Отлично.
Hello, guys. Thank you, Renat, for introduction. He almost told everything what is going to talk to you. So, as already mentioned, I am founder of Rolling Scopes community and RS School. I joined EPAM 15 years ago as .NET developer, but quickly switched to JavaScript related technologies. I have several hobbies. For example, I really like board games, but in addition, I like to give lectures, interact with people, and build community. So, giving lectures is my hobby for almost 7 years, and thanks to EPAM, he helps me to drive community, develop it, and maintain as full-time job since 2017. So, regarding the Rolling Scopes. Rolling Scopes is an international community of developers which we organized in 2013 in Minsk. Majority of our community members are JavaScript and Frontend developers, but also several years ago, mobile developers and data science engineers joined us to spread the knowledge and discuss interesting things together. If talk of very beginning, we focus, as I mentioned, just about JavaScript, HTML, CSS, and Node.js. We meet every month with our friends to discuss, to have fun together. Actually, we don't have any specific mission. Our mission was to have fun together. It's just, but if we have, it can look like this, for example. Connect software engineers, discuss, share new knowledge, meet friends, find new friends, and have fun. Okay. Since that, we have at least 80 meetups, but I don't know exact numbers. So last year we just stopped counting. Just a few photos. I really like it. And together with my friends, our community members, we travel around Europe and attend the conference in Madrid, in Paris, in Berlin. And this conference inspired us to have our own conference. So in 2015, we started our own conference in Minsk. And since that, we had it almost every year. Also, one interesting idea come to our mind why we don't have some day to celebrate JavaScript developers' job, and we invented it and celebrate every last Friday of May since 2018, and maybe in 2019 we have a meetup simultaneously in 24 cities. Which is very interesting for us. Right now, we mostly focus on on AWS, since it's really popular nowadays, and most, even front-end engineers should know at least something about AWS. So we working on new courses and organizing meetups in different cities. Like yesterday, we had a very first meetup of AWS user group in Tashkent. And right now, I would like to share some overview about our biggest project of our community is RS School. In simple words, it's free of charge community course conducted by Rolling Scopes developer community, but I very like Wikipedia, and Wikipedia inspired me and lots of our people. So if we open definition of Wikipedia, it's multi-language, free, online encyclopedia, and then written and maintained by community of volunteers through open collaboration. And this analogy help you to understand what is the RS School. We also a community of volunteers who drive education process and collaborate through open tools. Actually, we develop some tools. Right now, we are available just in 2 languages, not 300 as Wikipedia. And we have just 35,000 of students, not so many as Wikipedia, but still, last year we have over 500,000 mentors who involved our education process. So here's just a quick list of our components. So first component, a huge community, international, 9 countries. We have several principles and traditions. I will mention it in 1 second. Also, we use Discord servers and Telegram channels as main communication points. We have several education programs on GitHub, so everyone is welcome to create an issue, collaborate with our contributors, share it, use it. So you're free to do what you want. Lectures on YouTube, and we have own learning management system. It's also open sourced. We have around 20 contributors who supported and maintain for last about 7 years maybe. If talk about way of students inside our community, so most people join us as students, then some of them, less than 1%, just less than 1%, became an activist. It's people who help other students in education, for example, manage some issues, check our task, like first tester, like testers of our education program, our task, our platform. Then, unfortunately, just 5% or 10-5% managed to finish our program. So they're quite difficult. It's duration around 7-9 months, and some students spend around 20-40 hours a week to complete our modules. So quite difficult. And then around 10-20% became mentors of our school, so they teach next generation of students. It's like one of main principles of school. Also, we have trainers, contributors, speakers, for example, people who organize meetups in different cities, people who organize conferences, people who work on support, who give lectures, and so on. So over 500 volunteers in total. And teach it forward. As you already know, according to this principle, everyone study for free, but we not request, but just ask our graduates to come back to school and help to teach next generation of students. Open source philosophy, all materials are open source, and our management system also open source tool, so every mentor, every student can create an issue or fix a bug, or just to take a look how this works. As I mentioned, 2 languages, and majority of our students are Russian-speaking students, around 85%, and we have full stack of courses for about JavaScript, like JavaScript, Angular, React, node.js and AWS. Also, we have once a year course about machine learning and course about Android and iOS development. What else? Last year we have some events in 9 cities and 9 countries. We managed to help almost 2,000 people to graduate, and thanks for EPAM, around 250 of people joined EPAM as junior software engineers. Some of them joined as software engineers, like a middle at the very beginning. That's all about our principles. Thank you very much. And right now, Zafar, who graduated from Rolling Scopes in 2019, will share some information. Thank you.
Hey guys, thank you all for coming. I'll be short, and I would just like to tell you how rolling scopes in Uzbekistan has been started and how it evolved. So, let me first introduce myself. I'm currently a senior software engineer at EPAM and also acting as a resource manager of a unit with over 30 people. And I studied in Rolling Scope's short track school in 2019, and I've been excluded from there because of my bad performance. So don't be like me. Nevertheless, I'm now standing here and driving the Rolling Scope's activities in Uzbekistan. So never give up. Now let's get back to rolling scopes in Uzbekistan. So here is the first group photo we took during our graduation. And this was the course when I was excluded. But like we can see here people who studied in that course and graduated. Alex sitting here, the engineer with 15 or something like years of experience and studying in rolling scopes just for fun and lowering our self-estimation. Thank you, you're cool. And also Shoaziz, where is him? He's the guy, he was like 16 years or 17 years old and he was kicking everyone else and being the top scorer, and like no one could ever reach the score that he had, even the guy with 15 years of experience. And let's go further. Here are some photos with the first graduates. As you see, I got the graduate t-shirt even though I didn't graduate. It was just a leftover. Someone just didn't come and I was just, can you give it to me, please? Yeah. And then we have Munira here. I hope she joined us today. Munira, are you here? Yeah. I hope she will join later during the day. She was one of the first graduates and a person who also contributed and has driven lots of activities in the community. So I just wanted to pay credits for her contribution. And by the way, sorry for my bad haircut. And then, like, we graduated and we joined to the community and have started doing some local events. We conducted some offline workshops in the university that I will not mention, just for, like, so that no one can sue me. And then my clicker started not working or something. Okay, it works. Are you able to see the pictures, by the way? I think they are not readable. Do we have Sherzad here? Okay. Yeah, this is one of the first courses where I acted as mentor. And now we have guys here who graduated from that course, and now they are working as, like, some of them are senior engineers, some of them are working as leads in some other companies, and also contributing to the school. And we have guys who, like, are not mentors or students. They just enjoy our events and come every time to each event. Thank you, Muhammad Amin. He's here too. And now my clicker doesn't work again. Okay, we have the buttons. Yeah, and And then we also organized some offline meetings with the students of the course. We were just gathering in the office and discussing some technical topics from the course program. And then we were even doing some calls with remote mentors. And like you can see that Shazis is still telling some nerdish things and drawing the nerdish diagrams here. And then you can see that the amount of graduates, it has grown, and the number of mentors grown as well. And it was just like 1.5 years after the first Rolling Scopes course started in Uzbekistan. And I can see that some of those guys are here. I can see Sasha is here. Hi, Sasha. Do you like the weather today? And then the next round, here we have like more or less the same people as mentors, but still we are growing the number of our graduates. And this is like the whole group who came to the event. And then, as Dima mentioned already, we organized, like we had this yearly tradition when we organize quiz dedicated JavaScript Developers Day. And it's like a team quiz where you just battle with other teams to answer JavaScript related and web technologies related questions. And that was fun as well. I hope we can organize one more next year. And then we had several technical meetups. And yeah, here's another photo from one of them. And finally, we have lots of graduates this year who studied the last half years or 9 months, did great job, and we've got like even 10 or 15 graduates from one course, and it was like really much for us. And thank you all the mentors who helped the students and who supported us with their contributions. Now let's talk some numbers. So I told that Rolling Scopes in Uzbekistan has been started in 2019, and since then we've run like 10 plus courses. I mean that they were run globally, but we were promoting them and mentoring the students over there. And we've conducted like more than 10 events. I don't know the exact numbers, but it is definitely more. And I was just rounding them up just to look better. So like more than 40 mentors we've had in like 3 years who mentored the students, and 50 plus graduates that I'm proud of. And more than half of them are currently joining EPAM. I mean, some of them are already working, at least like 30 of them, and others are in the process of being employed. And let alone EPAM, some other students, they may find other jobs even when they start studies, in the progress of studies. So it doesn't mean that only 30 people are employed if it's EPAM. There are some more students who got jobs in other companies as well. And talking about future plans, what are we going to do next year, and like not next year, but next few months? So in December, we are planning to do a Rolling Scopes school meetup. And then in December 5th, we have the exact date for that one. We are studying the Stage 0 course. It may be interesting for those. I saw that there are people who don't have production experience and they are interested in IT education. In the list of people who registered for this event. So it may be interesting for you. We are starting the course on 5th of December, and it will give you all the basics before you start learning in the main course. And also, as Dima mentioned, we are also doing our friends are doing AWS meetup in December, and the details can be found in our Telegram channel, which you can join using this link, this QR code. So the main message I just wanted to deliver is that Rolling Scopes is an open community where everyone can join and learn, share their knowledge, and just have fun. And like, we can see that currently IT in the country is at the very, very beginning stage. And if we join our forces together, I hope we'll reach big amounts of IT guys in the country, and it will develop both the, let's say, like, it may sound really like ambitious, but we can improve the economy of the country and get more friends if we do more contributions in IT education. So teach it forward. We hope that those who are interested in our courses will join us and learn, and sometime later they will come back and help us to grow even more IT guys. So thank you. This is Rolling Scopes.
Okay, thank you very much, Zaf. I think it's more listening and hearing Zafarbek. It's pretty interesting because I'm... Okay, so let's talk about agenda before we start and get the first speaker. So, Marina, can you tell us about agenda of today's meeting?
Of course, sorry, I have some problems with my mic. We have prepared several contests for you today, so be active and you will be granted with branded gifts. So first of all, I would like to start with the group photo contest. Yes, I need to change the slide. And do not forget to join our Rolling Scope community. You may use this QR code. So take your phones or type Rolling Scopes US in the search bar of Telegram. 1, 2, 3. Next slide. And about contests, photo at the photo zone. Maybe you've seen that we have on the first floor our photo zone. So during the coffee break and lunchtime, you will have a chance to take a picture, preferably group one, and to post it in the Instagram stories. Do not forget to tag our Rolling Scopes community and also Westminster University's account as well. And it is also important to use a hashtag RSConf 2022. You may take a photo of this slide. And also we have placed some instructions on the walls.
Okay.
And show to our volunteers. Our volunteers are in branded t-shirts that you have posted the photo, and they will provide you with the branded t-shirt. Okay, so the next is memes contest.
Yeah, it's my contest actually. I like a lot of this. So what's the main point of this contest? So first come up with a meme. What it means. So it's not mean that you need to create something new or something exciting, something like that. You need to just check the Google, for example, and some developer's mem, and then create by your own. And then post a mem in Instagram stories and tag the Rolling Scopes account. So we will get the notification that you create your own mem. And then after, I think, break, one special guest from Poland, I guess, from Poland will choose the winner of this contest, and the winners get special Rolling Scope School power banks. And let's see examples what we mean if we talk about MEMS. So it's something like that. Okay, language HTML, yeah. Awesome. Let's go to next. And yep, tester also will like them. And next, yeah. It's usually what I'm doing every day, actually. So it means that you need to just copy something like that by your own and post on Instagram, something like that. And if you have some question, you can ask at the break for our volunteers, and they can help you and tell you how to do this, maybe. So let's go to the next contest, final. Kahoot. Marina?
Yes, this contest deserves a special attention because we have a special prize, electric scooter for the winner, a real one, which can be used in your daily life. So you should...
There is no electric scooter?
He told that it's really important to say from PVS Studio. From PVS Studio. I hope that it depends something important. Okay, so our ask to listen carefully to all talks today and answer the questions within Kahoot quiz. So the best and the fastest and the rightest participant will receive an electric scooter from PVS. Okay.
We'll like our sponsors, for sure. Okay, so let's go to the next slide. Oh, that's it. Let's finally start. Let's make some noise. We've done with final speech, welcome speech. Yeah. Okay, so let's go to the serious stuff. So
Yes.
our first speaker is Andrei Palchys, and his speech called "How to Manage AWS Cloud Infrastructure with Typescript." So, Andrei, mic is yours.
It really deserves to say that Andrei is a chief software engineer at EPAM. So the stage is yours.
Okay. Yeah. Thank you. Can you hear me? Good. Yeah, give me 1 second. Probably I should have some joke while I can see my laptop. Good. It's a pleasure to be there here today. And give me 1 second. Okay, you see nothing. Now you see this. Now you see nothing. Okay, and now you see my slides. Good. Not good? Okay. Yeah, as was said, my name is Andrei Palchys. I'm Chief Software Engineer in the PAM Systems. Actually, first of all, I'm glad to be in Tashkent, and probably this is like the first offline conference for me for quite a long period of time. I don't know, I really like offline conferences comparing to online, because anyway, meet new people, it's always fun, it's always pleasure. And today I'm going to talk about AWS Cloud and Typescript. But before I start talking, I want to make some disclaimers. My talk is targeted for JavaScript and TypeScript engineers, those who probably write front-end, write back-end using node.js, something like that. If you're back-end engineer or DevOps engineer, please don't be surprised because some things are simplified on purpose. Or maybe if you work in AWS, so I know maybe not everything is like exactly stated as it works, but I just wanted to give you idea, especially to engineers who knows JavaScript and TypeScript, how you can leverage your knowledge and how you can apply actually your coding skills to some new domain area. But before we start, probably some of you have at least two questions, like what AWS Cloud is and why actually I'm talking about it. Like, I expect that most of you are just developers, and typically this is not a task for developers, manage cloud or do something like that, right? So let me start from first question about like, what is AWS Cloud? And actually today we have a lot of talks about AWS and we have a guest from AWS. So I think it will be good to just briefly describe what is AWS actually. So AWS states, it's a acronym for Amazon Web Services. So Amazon Web Services is a huge, let's say, probably some kind of department inside Amazon that provides cloud services to everyone and everywhere, almost everywhere. Some quick facts, right? It was founded, actually released in public in 2006. Current revenue is 21 billion, approximately 21 billion in the last quarter. So you can probably imagine what size of the business, like, because if we, for example, multiply by 4, so they probably will make about like 100 billions per year. So this is more than GDP of many countries. They have more than 200 different services. Actually, I don't know exactly how many services, and probably not everyone in AWS knows how many services they have because there is no exact number anywhere. So I was not able to find how many actually services they have up to date, like, because it's always changing. And currently they have market share about like 35%. It could be a little bit more, could be a little bit less, but anyway, this is a major player, right? And they have, they're presented in 27 regions, different regions across the globe. Probably they exist on every continent. I know guys from AWS maybe correct me if I'm wrong, something like that. So, as I said, AWS currently is a leader in public clouds. This is top player. And yeah, it's actually, you could probably see, there is a famous company called Gartner, and just like probably 1 month ago, they released a new report, and they again confirms that AWS currently is a leader in among different public clouds. And actually, this is 12th year when they're named as a leader. And you can see on this famous, okay, I'm not good pointer. Okay, anyway. So as I said, they have more than 200 different services, and I have feelings that some developers think about AWS like hosting providers, where you can just rent virtual machine, maybe store some files, but it was true long time ago. Currently, they provide managed services for almost every area that you might need. Like, if you need if you need to work with blockchains, they have, for example, managed blockchain, right? If you want to work with machine learning, they have tons of different services how to work with machine learning. This is not just about virtual machines and some compute resources. This is about managed services that does something for you. For example, you want to detect fraud on your e-commerce site, they have service which helps to detect fraud, right? For example, if you want to prevent DDoS attacks, they have a service that helps to prevent DDoS attacks, etc., etc., etc. So, what just I'm trying to say is that AWS ecosystem is very huge, and probably this is very useful to use their services, especially if it could speed up development. That you don't need to spend 1 more year to develop something if you can just start using it from AWS. So this is like my answer to the first question, like what is AWS, right? The next question was like why we need to know about AWS and manage it, like why do we care about it? And I wanted to answer to this question starting from such term like full stack developer. This is very, very popular role, or yeah, let's say role. Many developers want to be full stack engineers, right? And currently when we are talking about full stack, usually it means this is a developer who can write front-end and back-end. Usually front-end, this is something using JavaScript or Typescript, and if we're talking about backend, this is typically development using node.js or sometimes using different other languages like Java, etc. But typically, full stack does not include anything what will help you to deploy what you did, right? For example, you created application, you develop very perfect UI, you develop perfect backend, but typically you don't know how to deploy it, how to manage it, how to deliver this value to your customers. Yeah, and what I'm talking about, usually it's called like DevOps. This is like, let's say, some kind of abstractions on many different things that includes infrastructure management, deployments, automation, etc., right? I think today we will hear more about this from next speakers. And but currently, from what I see and from what we are doing, usually DevOps is still about coding and some automation. No one in large scale projects or products do something manually when we're talking about DevOps. It's still about writing code, right? It's about writing code, committing to repository, doing almost the same steps that front-end or back-end developers do. And if you want to be a full-stack engineer, yeah, this is like, typically like infrastructure is a code today. You need to keep your infrastructure as a code because it's easy to repeat. You don't need to do anything manually. And if you have a really huge team, doing something manually is not an option because you can easily lose your infrastructure. So, and my primary goal today to tell you that you can actually know in TypeScript or JavaScript, you can be not only full stack developer in terms of front end and back end. You potentially could explore other directions and probably start learning DevOps, how to be DevOps engineer, something like that. I'm not saying that I will show you how to become an expert and like true DevOps engineer, but at least you can try to touch this area and understand how deploy your applications. Before we go, I think I need to explain how actually what's our options to work with AWS, right? Imagine we have AWS, we are ready to use it. We want to use some services from AWS, right? But what's our communication? Like how we can do this? And sorry. And actually, Amazon provides several ways how we can do this. There is a sorry. Just give me 1 second. Amazon provides CLI, right? Command line interface, where you can create or manage any service using command line tool. You can also use SDK from AWS, where you can use using your favorite language. You can call API from AWS and again do something. I will show you examples later. There is also REST API, where you can just make HTTP requests again from your favorite language or favorite tool and create something. Or you can use a managed service from AWS called CloudFormation that provides a way also create infrastructure in a kind of different way comparing to other options. And before I tell you what the difference between them, probably I need to tell you about two, let's say, paradigms in programming. There is a paradigm called imperative and declarative. So imperative, this is when we tell computers what to do. Like, it's an answer to the question how. Like we give exact commands, like what to do, right? And declarative, this is when we declare what we want to achieve. And computer decide how to achieve this, right? So, and now I have an example to demonstrate to you how those methods that allows you to work with AWS actually work, and what's the difference between imperative and declarative. For example, let's imagine we need to have a place in cloud where we can want to store our assets. For example, we don't want to use our local machine because it's not very reliable, etc., etc. And we want to start using AWS, right? AWS has a service called S3, simple storage service, and it allows you to store files. It's very reliable, it's very popular, it's very, I know, probably one of the best ways how you can store files remotely. And for example, there is one option how we can start storing files. It's to create a bucket. Buckets, you can think about it like a folder, right? And for example, using command line interface, we use AWS command line utility, right? And execute some command. And this command will create a bucket. For example, if I execute this, it will create bucket RSConf in a region called South 1. It's Mumbai, probably, if I'm not wrong. This is probably the closest region to Tashkent available in AWS. Another way to do this operation, for example, we can use SDK. Here is a Typescript version of SDK, where again I explicitly tell create a bucket called RSConf in some region, right? But talking about declarative way, it looks a little bit different. This is how this example will look like in CloudFormation. I also specify that I want to have RSConf bucket, right? But I don't tell, there is no any action on the screen. I just tell what I want to achieve. And it's a job for this service to create this bucket. So this is a difference between like imperative and declarative. Like in imperative way, you have some actions. In declarative, you just describe what you want to achieve, right? It's like, imagine like with a dream, right? Imperative way, this is like doing something towards your dream, and declarative, you just describe like, I want to have a car, and car will appear without any actions, right? So this is a funny example, but anyway. And today, declarative is the most popular way how to manage infrastructure, how to manage services in AWS. There is a solution that I mentioned before, like CloudFormation, but there is other solutions from third-party companies like Terraform and others. But anyway, this is a primary way how typically DevOps engineers manage infrastructure today on large-scale projects, right? And declarative have like obvious benefits, like idempotency. Means no matter how many times I will try to execute declaration, I will get the same result. Again, we describe what we want to achieve, not how to achieve. And also there is like, for example, state management provided as is for us. We don't need to manage state in any way. From the other side, declarative way, like I mentioned before, using JSON, right, has some downsides. For example, it leads to a lot of duplication. For example, you want to create 10 buckets, you need to copy the code that I showed before 10 times. You can't use like just for loop or something like that that we typically use when we develop, right? There is some complexity because, for example, if you have a like really huge infrastructure, it becomes not so easy to manage everything in different JSON or YAML files. Because again, it's very easy to make a mistake when you have thousands of lines of JSON, right? There is a ways how you can validate, but anyway, it brings some level of complexity. And like another point is developer experience. For example, if you use JSON or YAML, you don't have typical, suggestions from your IDE when you use TypeScript, for example. There is no types. There is no easy ways how to debug something, for example, right? Because we, as developers, we mostly work with programming languages, not with JSONs, YAMLs. And there is a solution from AWS. It's called Cloud Development Kit, or SDK. This is a framework that allows you to define your infrastructure using code, and it tries to solve the problems that I mentioned before. This is just some quick facts. It has support for multiple different languages, like TypeScript and JavaScript, obviously, Java, Go, Python, C#. It's open source. You can easily go to GitHub and to see how development goes. And currently there are 2 active versions. Actually 2 versions, one in maintenance and one active and latest, like V2. And now let me tell in details how it works. So imagine we have TypeScript file. So we wrote something in TypeScript. I will show you later how it might look like. Then we pass this file to CDK, right? And CDK executes this file, generate JSON file, declaration of our infrastructure, and then pass this JSON file to CloudFormation. And Amazon creates what you want, right? So this is how our example will look like in SDK. Sorry, CDK, not SDK, CDK. It's very similar to how you will use SDK, but again, there is no any action here. Yeah, like we create a new object, but this is just like creating an object. There is no any operation like create, update, delete, or something like that. And when we have code like that, later we can just call CDK deploy, and it will deploy and create what we want. And actually, under the hood, it will generate JSON like that. It's it will be very similar, actually, to what I show you. But actually, it generates a little bit more. There is some metadata, but I just skip it. And some of you who front-end engineers might think that it's very familiar for you. That we have TypeScript, we write something in TypeScript, then we generate some declarative structure and execute it, right? And what I'm trying to say is that it's very, very familiar, similar to React, for example, how React works. Because again, we use J6 or T6, right? We write code. Later, React generates HTML for us, and HTML executed by browser. Here is a very similar idea. We have TypeScript. CDK generates JSON, and JSON passed to AWS, and we get result. It's executed. And actually, it's funny that there is an idea and proposal for CDK to start supporting J6 for defining infrastructure. Maybe someday in the future, it will be possible to write UI and infrastructure using the same, let's say, markup language. Actually, there is not so much support for this proposal, and I guess it will not be implemented in like nearest future, unless someone wants really push this forward. So now let me tell you about some key concepts of CDK as a framework, right? So the first primary concept is construct. And as I said before, since CDK very similar to some UI frameworks, you may think about it like a cloud component. So this is just component and basic building block for your infrastructure. For example, here's how it typically looks like. We create class. We inherit it from base construct class, and then we define inside what we want to create or achieve inside this construct. And again, you might see that there is not so much difference, for example, between this code and code that we typically write when we are using React before hooks, right? We also have class component, we also extend it, and then we also have props, for example, and then we do something inside. And if we, again, start comparing, for example, with React, we have, it uses the same patterns, like there is a preference to use composition over inheritance, right? We have, again, props, typically. We also, for example, can use snapshot tests to test our code, because, again, this is actually one of the problems. When you define your infrastructure in JSON, okay, you have JSON, it describes how it should look like, you execute it. But when you start writing code, then probably you will create a bugs, and then probably you need to test it and start writing unit tests for your infrastructure code. Also, by the way, AWS provides some construct library that helps you define everything using different types of constructs. There is a three layers, like layer 1, layer 2, layer 3. Layer 1, this is basic primitives, like low-level constructs that maps one-to-one that CloudFormation provides. Layer 2, this is a construct that focuses on some scenarios or on some intent. And layer 3, it's about some patterns, when very complex scenarios, when you need to, again, in terms of, for example, React, this is layer 3. It's very similar to smart components, or maybe even to pages, when we have multiple different operations inside. And for example, like layer 1, right? This is, we created just a bucket using layer 1 component, construct, sorry. Nothing special, right? Layer 2, we do the same. It looks very similar, but for example, we have possibility to auto-delete objects. And to do this, we just need to set this flag to true. But under the hood, this construct will create a function that will delete your objects when you're trying to delete your bucket. Because by default, when you're trying to delete your bucket, it will not be allowed to delete it if there are some files exist inside bucket. And layer 3, this is, for example of construct that allows you to copy your files from your local machine or server to S3, because typically this requires many different actions. So this is some kind of, let's say, pattern that you're, for example, if you deploy something, then you can use this construct. Okay, let's move on. Next concept, it's a stack. This is basic unit of deployment in AWS. You can't deploy construct. You need to deploy stack. And stack is just a set of different constructs that relates to each other. You may think about stack as about page, for example, if you front-end engineer. And another concept, it's a app application. This is just a container for multiple different stacks. And again, it's very, it maps to front-end, like where we have application, it has multiple pages, stacks, and each page has different components, constructs, right? So here's like a picture how it typically looks like. And so red stack, this is what we might deploy. And there is no option that it could be deployed partially. Stack could be deployed or reverted. There is no any possibility to deploy partially. Okay, but what I said before, I was talking about AWS, right? And AWS and CDK. But actually, today, CDK is not only about AWS. I think guys from AWS decided to make it more generic way how to manage infrastructure, not only inside AWS. And currently there is an option to use CDK for AWS and, for example, for Kubernetes, no matter where it's deployed. Or actually there is an option to use CDK for Terraform, provided by companies that created Terraform. I forgot the name. And there is a site called constructs.dev where you can find different constructs and start using them. There is a constructs provided by community, for example, where you can find, construct how to, for example, how to deploy or set up Datadog, provided by Datadog company. This is a company that specialize in logging and monitoring solutions. And I think the idea behind of this that you just go to the site, find constructs that you needed to build your infrastructure, and probably you can do this in hours or days instead of weeks as before. Because there is so idea of reusable infrastructure components written in your favorite language. It's a quite powerful thing if you especially wants to give this power to developers. So, like my general advice is, so please try to use it if you want, or if you're interested, and especially if you have knowledge in TypeScript, then you have everything what you need to start using it. Like you probably don't need to, to be like real expert, but on the other side, CDK does not make you AWS expert. So you still need to know technologies that under the hood, like how CloudFormation works, how actually AWS works, how network works, but CDK is a good start for you, start exploring new ways for example, for your career or for your self-development. And yeah, basically, I think this is all from me about CDK. But since my presentation says just about AWS and TypeScript, there is other options how you can use TypeScript for managing AWS. And another option is Pulumi. Pulumi, it's a company that provides you API, actually different, not API, CDKs, how you can, again, manage infrastructure using TypeScript. It's very similar to CDK in some way. Probably you will, like, if you're new to this area, you will not see any difference. And like, yeah, there is a fact that CTO of this company was co-founder of TypeScript, co-creator of TypeScript when he was in Microsoft. So Pulumi has a great support for TypeScript. And here's the like screen from that side, and you may see that again it's looks very similar to what I showed you before. It's again just TypeScript. You import something, you create new objects, and it's done. You get your infrastructure ready. Okay, I think that's all from me. Any questions? And yeah, by the way, if you I know, shy to ask questions now, feel free to find me today and ask questions in English or in Russian if I speak Russian.
Yeah, that was great note, because we a little bit running all the time, so we have just time for 3 questions. So, Andrei, you can please raise your hand, and Andrei, you can choose who will ask a question. Okay, please tell a little bit louder, yeah, because we don't have mic for crowd.
My question about full stack developer and DevOps role. You have said that DevOps is, I understand it, that this is like a delivery manager. This is front-end developer, and also this is delivery manager. Because I work in retail, DevOps is a CI/CD, this is administration, this is hardware, but not so code in Russia, I say in Russia. And that's why my question, this is only about AWS developer when you say that front-end, this is full stack front-end, back-end, and DevOps, or for some different stages, some different projects? Thank you.
Yeah, yeah. When today I'm saying about DevOps, this is more about what DevOps do in terms of AWS cloud. Right, so again, this is like back to my initial disclaimer. I didn't want to offend anyone, and I'm not saying like actually like real full stack engineer exists, because like knowing everything like from, let's say, client to how network works and how servers works, it's not possible, I believe. So when I'm saying about DevOps, this is typically like from my experience, the job that, for example, you have a, for example, Docker container, or you have a Lambda function and you need to deploy to AWS. There is many cases when developer just write code and he or she doesn't know what happens with code, how it's deployed. It could be very simple actually action, but we need sometimes a special team who knows how to press button or run some scripts. This is what I'm saying about DevOps in these terms. In red, or similar to red.
I have a following question. You said that AWS CDK are just like libraries to use AVS more comfortable. And can you use them also using, for example, Minikube to fool around on the local machine, stuff like that? And also the same with Pulumi. Does it work with Minikube?
Actually, I'm not sure. What is Minikube?
Minikube is a smaller version of Kubernetes.
Okay, I get it. No, actually, I have no idea. Right. So my experience with Kubernetes is very, very small. Yeah, I think those guys know, but my experience with Kubernetes is very like limited, and yeah. And actually, I know that CDK is very tied to CloudFormation, so probably it's not an option, but probably you can. Okay.
I will go very fast. In CDK, you can do CDK for Terraform, CDK for Kubernetes. It means like you can create any resources for Kubernetes. So if you speak about Minikube, yes, through the CDK you can create resources for Kubernetes. But the main idea of CDK is create resources outside. I mean, like for AWS resources like EC2, S3 buckets, all of the stuff. But yeah, some local resources you can try. I mean, like to try to play. But as usual, as in other languages, it's like library or framework where you have to be familiar. I mean, like what you're working for. I mean, like with AWS or with Kubernetes, it will be very different. Like I don't know, Vue.js, React.js, you have to be familiar how it works with different libraries and frameworks. I hope I answered the question. Sorry.
Hi there, my name is Mikhail. So my question pretty easy. Have you tried find ops, DevOps on project where everything described by Node.js?
Thank you for your question. Actually, I wasn't telling about my experience, but for example, I work in 2 projects using CDK, and on both projects we didn't have any DevOps. So currently I'm working on a project, and we have one guy who actually writes just CDK code and supports all infrastructure for multiple projects. But for example, in my team, there is no any dedicated role for DevOps engineer. And we have actually cases when let's say junior React engineer writes CDK, at least modify CDK. He or she knows how to, for example, create a 3-bucket, SQS, Lambda, some other things using CDK and following patterns. So CDK is a very good actually tool when you have a team and you can hire DevOps engineers. Then probably you can teach developers how to do this by themselves. Is this answer or? Yeah. YAML? Well, I have experience writing, let's say, couple of thousands of YAML in CloudFormation, and I want to repeat this. Never. So this is very, very hard to write, especially when you have a huge infrastructure, and especially if you use many, like, let's say, 20, 30 different managed services from AWS, and when they are very connected, and you have multiple applications, and when you try to describe this everything in cloud, just in YAML, using CloudFormation, this is it's crazy. Yeah, but fast. But again, you need to modify, manage, especially when you develop something not very so stable. For example, when you change, experiment, because this is what actually AWS does for you. Like you can easily use different services, very easily experiment. So yeah, I'm not saying that CDK is it's an answer for all cases, but it's very good in some cases when probably you don't need to separate, I know, DevOps team, or when you have a very like smart DevOps team and who actually capable to write in TypeScript and wants to to do programming, because it's also not very easy to find like very good DevOps engineer who knows how to code and who knows how to write, for example, unit tests.
Okay, thank you very much, Andrei. Let's
Thank you.
say thank you for Andrei. Thank you. So, before I will, first of all, each who asks question can get the T-shirt, so that you prepared your question, ask your question. You can go to our volunteers and get T-shirt for that. And before I present our next speaker, I'm just curious about how many people knows what is serverless? Can you raise the hand? Okay, nice, nice. So our next speaker is Principal Solution Architect in Amazon, and his speech called How to Manage, Getting Started with Serverless in AWS. Mike Golubev. Mike is yours. Hey, let's say hello. Yeah.
All right. Can you actually hear me, or do I need to take another mic? Is it okay, especially on the back rows? No, you can't hear? Sergey, will it be possible to just stream this one and for me to speak on that mic? Test, test, 1, 2, 3. 1, 2, 3, test, test. All right.
We thought about that for the greatest question. We will the person who will ask the greatest question will get a T-shirt, but from AWS. Okay, so one more time. So if you want to get T-shirt, ask your question. But Mike, after his speech, will choose the best of the best of the best. And the best of the best of the best will get the T-shirt from AWS Amazon. Yep. Am I correct?
No? That's
Yeah,
right.
we can hear you.
Okay,
You can
perfect.
start.
All right. Let's kick it off. Indeed, my name is Mike Golubev. I'm Solutions Architect at Amazon Web Services, and I mostly work with digital native businesses and independent software vendors. And what this means is these are the companies that were born in the cloud, and they basically follow the cloud native patterns. And there are quite a number of these patterns, and serverless is one of them. So I see quite many people actually already know what serverless is. So another question, who knows any serverless service in AWS except for Lambda? Not that many. All right, then hopefully you will learn something new from the presentation today. So first, let's kick it off. And for those of you who don't know what serverless is, let me explain a bit the history and how we came here. So first, we started with the paradigm of physical machines in the data centers. So we basically were just putting servers there, we were putting the application directly on the servers, and that's how it was working. But then we realized that basically this means that there are too much resources spent ineffectively. That's why we have introduced the virtual machines that allowed to pack more applications that cannot probably be on the same machine actually on one server. Then we started moving to containers. That's about the time when the cloud came. And containers were really an efficient pattern to deploy the applications in the cloud, so they provide a good level of abstraction, but still with the containers you need to manage the infrastructure. Like for example, with containers, if you deploy Kubernetes that we were speaking about in the previous session, you need to deploy the Kubernetes nodes. If you use other container services, like for example, we have Amazon ECS, Elastic Container Service, you still need to add nodes into your cluster and you need to manage these virtual machines. That's why we have moved to the next paradigm, which is called serverless. And I think you all understand when I say serverless, it doesn't mean that there are no servers. Well, there is no magic. There are still somewhere servers out there. So there are still servers in AWS data center. But what we mean when we say serverless, it's first of all the continuous scaling. So this means that the application scales with the request from your customers. So you don't need to think, oh, how do I configure auto scaling? Do I need to add additional virtual machines, anything like that? So the service handles this for you. Then another thing is that there is fault tolerance built in. So you don't need to think, oh, do I need to deploy in one availability zone or in several ones? So how do I make sure that my application stays alive? So again, AWS takes care of that for you. And then another important thing is, of course, the cost. So with serverless services, you pay for what you use. Of course, there are some optimization mechanisms where you can reserve some resources and pay less for them, but overall, the idea is that you only pay for what you are using. And the final thing is zero maintenance, and that's super important. So I was recently speaking to a CTO of one of my customers, and he was at a conference where the company were presenting the use case that they went to serverless with AWS, and actually they had 0 security patches or 0 maintenance patches over the last 5 years. So imagine how much effort it can save you to go to serverless. So this basically means that you can focus on the business value, so you can focus not on maintaining the infrastructure, and of course I like CDK as well, but like with serverless, you can actually focus on your code and on your business application. So, and that's basically the main idea of my presentation will be now in this slide, and then I will just go deeper into it. So serverless is not just compute. So first, of course, compute is there. So there is Lambda, which is our serverless function, and I will speak more about it today. And then there is Fargate. So Fargate is a way to run containers in a serverless manner. Like, let's say you have a Kubernetes cluster. You don't need to add nodes into your cluster. You just fire up your pods, fire up your containers, and they work. So that's it. Then another layer is the storage layer, and here is both structured and unstructured storage. So there is Amazon S3 that, again, Andrei has mentioned in the previous presentation, so I will not go deeper into it. It just allows you to store objects, and you only pay for the storage and the requests to it. And then there are relational databases. Amazon Aurora is our relational database that can be run in MySQL or Postgres interface compatible mode, and it can also run in a serverless manner. So again, you don't need to scale it. Just like you take a regular Postgres, but it scales automatically for you with the requests that are coming, and it's fully transparent, so there are no like transactions dropped at this time. And there is Amazon DynamoDB. It's a NoSQL database, and I will have more about it in the presentation later on. Then there are a number of integration services, and that's super important, especially in today's world when we speak about microservices, decoupled architectures. So these integration services, I will not speak about all of them. Basically, they allow you to both create the queues, pub subtopics, and put them in between your application components. And you can also notice that there are some services here that are AWS native services, but there is also Amazon MQ, which allows you to run Apache ActiveMQ or RabbitMQ, so open source tools in a managed manner. And that's overall a philosophy of AWS, that we oftentimes provide both the native service and an open source managed service, so that you can choose, like if you just start in the cloud, you can go with the native because it provides the best integration to other services. But if you already have experience with, let's say, ActiveMQ, we are not saying, no, you must migrate to, let's say, SNS. So you can keep using it, and even in a serverless manner. And finally, streaming. So some services, again, one native and one based on open source, Apache Kafka, to manage the streams of events. So streams of events is basically, let's say you have a device that measures the temperature in this room, and like each second it sends a JSON document to the server with the information about current temperature. So that's the stream of events. Of course, these are not all the services, so we have several more, so to say, layers on the server's front. Like, for example, we have analytics services which allow you to build data warehouses or data lakes to analyze huge amounts of data, so big data, which is now really popular. But these are probably the key ones. And overall, like one small comment here is that when we look at the services in AWS, it's not just serverless or not serverless at all. So it's actually a range, and you can choose yourself. If you want to go self-managed, just deploy into EC2 instance, you're okay to do that. Then you can take some managed services that take some responsibility from you, or if you want to get the least amount of responsibility and push as much stuff as possible to AWS, you can go serverless. And by the way, you can also mix and match different components within one application. So it doesn't mean if you go serverless, that's like 100% serverless. So now let's look deeper into three services. So I will be now speaking about AWS Lambda, Amazon API Gateway, and Amazon DynamoDB. So these are probably the key services that are met in most of the serverless architectures. And in my demo later today, I will be using them. So let's start with the Lambda. As I've said, Lambda is our serverless function. And what we mean when we say function. Function is actually a piece of code that can be created either in one of the default languages that are available out of the box, like Node.js, Python, Java, and so on, or you can actually bring your own runtime. Like, let's say maybe you develop in C++ and you want to run C++ in Lambda. You're free to do that. So an important thing with Lambda is that it is event-based. So you can see that the function gets triggered by event source. So it's not like it's running all the time. So something must happen, and again, I will show some examples of event for the function to be invoked. So when the function runs, we call it invocation. And then the function, of course, can speak to other services in AWS Cloud or somewhere else. And that's how it looks like. So you can see that there is a handler. A handler is basically the main part of the function. It is called when the event gets triggered. And it gets the information about the event itself and about the context. So the event, let's say event, a user has placed an order on our website. And then what you might want to pass in the event is probably the user ID, or maybe the products that the user has ordered, and so on. And the context is kind of technical information that Lambda function provides itself to you. And I wanted to mention a couple of configuration options for Lambda, at least the basic ones. There are quite a lot of them. Even though it's serverless, we still allow you a lot of control to be able to customize it and limit it according to your requirements. So one thing is the resource configuration. With Lambda, you can define how much memory your function will get when it is invoked. And that's actually a super important thing to think about, and we have tools that help you. Like, for example, on GitHub, you can find a tool called AWS Lambda Power Tuning. And it just runs a series of tests of your Lambda function, kind of performance benchmarking, and defines what is the best amount of memory for it. And now, I think like earlier this year or late last year, we have released an integration to Compute Optimizer, which actually, if your function already runs in production, it can tell you, is it optimized or is it not? So should you increase memory or decrease? And by the way, that's not really obvious. So you might think, well, if I decrease memory, then I will pay less for my function, so let me just go ahead and decrease it. Well, it's not always the case. Like, for example, you might want to increase the memory. Because of that, Lambda will also increase the amount of CPU and networking that your function gets. And your function will run faster. And as with Lambda, you are paying for each millisecond that your function is running. So with more memory, you're actually paying more for memory, but you're paying less for the seconds that the function runs. So in the end of the day, you will pay less, and your users will get a faster response. So that's why it's so important to think about performance benchmarking, because it's not always that obvious. And then another thing are permissions, and I will not go deep into it, but just for understanding, in AWS, there is no magic. Like, it's not possible that one AWS service in your account will suddenly start speaking with another AWS service in your account without you knowing this. Or it's not possible that, for example, AWS employee can have access to your data. So it's simply not possible. You are defining the permissions yourself. And the same is with Lambda. So if you want your Lambda to speak to another service, like let's say to some database, you need to provide corresponding permissions explicitly, so it will not just work automatically. And of course, we recommend to always follow the least privilege access principle, which means that don't provide to your Lambda, like for example, admin permissions to the whole account. Just provide whatever is important for it to speak with. Then a couple more things for the Lambda configuration. So one is the timeout. Maximum time that Lambda can run is 15 minutes. That's why, as I've said, it's based on events. It cannot run constantly. And the longer the function runs, the more is the cost. As I've said, you're paying for each millisecond of the function to be running. And, but an important thing to consider here, and you can see I've provided example of API gateway, is that your upstream systems that stay before Lambda, that send the events to Lambda, can actually have a different timeout. So it might be smaller than 15 minutes. So take into account and think how you want to execute Lambda. Maybe you want to do this asynchronously, so that, for example, your upstream system sends a request, receives the reply, okay, the request is accepted, and then Lambda keeps executing. Another thing is network access. So by default, Lambda is not running in your VPC. And if you haven't worked with AWS much before, VPC is your virtual private cloud. So it's a part of the cloud where you define your IP address range, CIDR, and that's where most of the resources like databases are located. But Lambda is not. Lambda is not in your VPC. And please do not add it into VPC unless you need it. Unless you need, for example, your Lambda to access the database inside the VPC. So it doesn't add security. And the only purpose of Lambda being added to VPC is to access something that is already there. So now finishing with the Lambda, a couple of thoughts to keep in mind. First of all, Lambda functions are stateless. So there is no affinity to the underlying infrastructure, underlying nodes. So what this means is that, let's say you have 100 requests from your users coming each second. And each of these requests can actually be routed to a different node, to different virtual machine with your Lambda function inside it. So you cannot expect that if you save some data, let's say to TMP directory, that it will be there. Another thing, as I've said, event triggers an invocation, and it's only event. Events can be different. Event can be a click from the user on the website, or it can be a timer, like let's say once a day, but there still must be some event. Then Lambda can handle different types of events. So it might happen that, so Lambda always receives just one event. But it might happen that within one event, there is more than one event from the upstream system that are batched. Like, for example, with my example of the temperature sensor. Let's say it sends the information each second, and you don't really need to execute your Lambda function each second. Maybe you need to just summarize the data for 1 minute. Then what you might want to do is to batch the 60 seconds of events and send to one Lambda invocation. So that's a possibility. Then Lambda manages the scaling and invocation for you, so you don't need to define the limits. Of course, you can do this if you want to limit the potential spend, but overall, it's not something that you need to configure, like 80% CPU scale up. No, that's done for you. And as I've already mentioned, Lambda team maintains the platform, including its security, so you don't need to think about operating system or any kind of interpreters or anything like that. So the main point is that you can go and build something that is important for you. Now, another thing that we have is API gateway. So API gateway usually sits in front of Lambda or some other systems or some other backend systems. And it provides HTTP access to them. So there are a number of different features that it has, so like throttling, caching, authorization, some different usage plans, and so on. So, but basically, it's kind of a proxy that does some additional business logic to avoid putting it on the backend. And I'll now show an architecture. It's a bit complex, but just for you to understand how it all fits together. So let's say we have some backends in AWS, and as I've said, with microservices, they can be on different technologies. So some can be on Lambda, some on EC2 instances, and so on. Then we have some publicly accessible endpoints, so maybe located in your on-premises data centers, or maybe it's some partner service like Datadog that was mentioned. And then, yeah, here we go. And then we have the on-premises. So in the AWS cloud, what you have is the API gateway, the piece in the middle, and it is responsible for routing the requests between all of these backends. So you can treat it as a central hub for all the requests. It also might have some caching, and it also has the monitoring. And then depending on where the consumer is, where your client is, you would choose from one of the 3 types of API gateways. So they can be private, and only you can access them, so they will be sitting inside your VPC. They can be regional, so they will be publicly accessible. Of course, if you have authorization, then they will be protected. Or if your users are spread around the world, you can have them edge optimized, and this means that they will be created on our CDN, Content Delivery Network, called CloudFront. And we have a lot of CloudFront points of presence around the world, and what this means is that, for example, some throttling can be done directly there, so your user doesn't need to wait for some time to get a response back. And then the clients can be actually any types of clients, can be mobile applications, can be web applications, or can be just some services running in other, for example, EC2 instances. And the last thing about API gateway is that there are 2 main types of APIs available. So those are REST APIs, which probably most of you know. So that's basically quite flexible API available over HTTP. And then we have WebSockets. WebSockets are used when you want to have a 2-way communication for your application, like, for example, some chats or any similar functionality. And then you might have a question, what about GraphQL? So as I understood, there are a lot of people focused on the front end here in the room today, and you're probably familiar with GraphQL. So GraphQL is not supported in Amazon API Gateway, but we have a separate service. It's called AWS AppSync. It's also a serverless service, and it provides you the GraphQL functionality. And the final third service I wanted to speak about before getting to the demo is Amazon DynamoDB. So as I've mentioned, DynamoDB is NoSQL database. I would actually, so officially it's categorized as key value database, but I would put it somewhere in the middle between key value and document database. And what this means is that as compared to relational databases like MySQL or Postgres, you don't have tables with relations, keys to each other and so on. So you basically have this kind of flat structure. And the benefit of that is that you can retrieve the data really fast. So it gets to almost unlimited throughput with single-digit millisecond latency. And it's often used for applications like, for example, leaderboards in different games, or for some data that needs to be retrieved really fast and updated really fast in your app. And of course, it's serverless. So now let's get to the demo, and I'll start with the traditional architecture, because what I will be building in the demo is a web application in a fully serverless manner. So before we do that, let's look at what we had previously. So this is what we had as a three-tier architecture. So we had the presentation layer, the web service, then we had the application service, where the business logic is, and finally we have database service with the logic. Well, it's simple, it's functional, but unfortunately not always it provides enough capabilities to move as fast as you want to. So that's why this is how we see the modern architecture of the serverless web application. So you can see that it looks quite similar. So it has presentation, business logic, and data layers as well, but there are some key differences. So first of all, you might see that there are microservices here on the business logic level. So each microservice is responsible for its own business function, and you might have tens, hundreds, or even thousands of them. Like in AWS, we also built based on microservices, and we have really thousands of microservices, sometimes even one service of AWS, like for example, EC2 has thousands of microservices powering it. But I will not be focusing on this today, so that's a completely separate topic, which is quite broad about breaking down monolith into microservices. So the next piece that I actually wanted to mention here, an important difference, is queues and messages and events. So the way how your application components or microservices speak to each other are based on this asynchronous patterns, or potentially you can use APIs in between as well. And the final important thing here are purpose-built databases in the bottom. So what we mean here is that when you build with microservices, you don't need to select just one database to rule them all. So you can have each microservice with its own database. Like maybe, for example, as I've mentioned, maybe you are building a game and you have a leaderboard. For it, you would use DynamoDB. But probably you take some payments from your users and you want these payments to have relations between, let's say, an invoice, a payment, and maybe some other accounting things that you have. Then you would probably use a relational database for this part. So that's absolutely fine to do this mix and match. And finally, this is the demo architecture. It's based on the workshop, so you can find the link here. If you are interested in building something similar in your AWS account, you can take a look there. But there are like three main components here. So the first is AWS Amplify, and I will not be speaking much about it today because my colleague Egor will have the presentation right after myself, well, after coffee break actually, where he will speak about Amplify and explain how you use it, but the main idea here is that you use Amplify to build and host your front end. Then we have the authorization and authentication piece, Cognito, Amazon Cognito. Again, we'll not be speaking much about it, so it's here just to provide the functionality of this website, but in fact you can use any authentication service. Maybe if you are familiar with Auth0, they're also a AWS partner, you can use them as well, so that's fine. And the main thing that I will focus on is the bottom line. It's actually the backend, which is fully serverless. By the way, Amplify and Cognito are serverless as well. So the backend will be this standard architecture that I was already showing. So you have API gateway as a proxy first, then Lambda executing the backend itself, and then Amazon DynamoDB, which is the NoSQL database, which will store the information. So what we will be building is a ride-sharing service, but instead of ordering a taxi, we will be ordering unicorns that will come and pick us up. So let's start with the video. So I've recorded the video because there are some parts of the demo that are quite long, so I didn't want to spend your time on this. So what I'm doing right now here is I'm creating a repository, Git repository, where my code will be stored, because it will be important to have this kind of built-in CI/CD process. And actually, as we are a bit out of time, and I'll try to speed up the process a bit, so I'll skip this part, because probably most of you are familiar how repositories work, so what is GitHub and so on. And let me go a bit further. So here I'm just checking out the code of this website, and then I'm pushing this code into a new repository that I've created. And here's the Amplify. Again, as I've said, I will probably skip this piece as well with the Amplify, because Egor will speak about it. But the main idea here is that with Amplify, you can either build from scratch your front end, or you can use the existing one. And in my case, that's an existing Vue.js front end, and I'm just putting the place where it is located, in which repository. And then actually Amplify does everything else for me. So it has identified that I'm using Vue, as you can see up here in auto-detected frameworks. All right, sorry, I switched to the next part of the demo, but basically, so the only thing that I need to do here is to set up the permissions. As I've said previously with Lambda, there is no magic. Services of AWS in your account cannot speak to each other without you allowing this explicitly. So that's what I'm doing here. And oh, actually, I'm sorry, that's a bad pattern. You shouldn't use administrator access. As I've said, least privilege access is the best one, but probably I just wanted to do it fast within this demo. But what I'm doing here is I'm allowing Amplify service to speak to other AWS services, like including, for example, code commit, where my code is stored. Actually, I've just realized it's not administrator access, it's administrator access Amplify. No. I did everything fine. So let me then skip through this, because Egor will be showing it. So the main idea, oops, skip too far away. So the main idea here, so now I have configured Amplify, so it's running through CI/CD pipeline, it provisions a new environment, it builds my application and then deploys it. And now I'm just opening my front end, and this front end, this would be our website folder in the unicorns. But you can see for now that's just the front end. It doesn't have any backend available or anything like that. It works. So let me skip a bit further. So here I'm just showing that the CI/CD pipeline works. So I modified the front end a bit and then show that the changes were propagated. So let's skip. And then the next thing that I'm going to do here, let me remove the mouse, is I will add the Amplify, and here speed up the process really fast, because again, I didn't want to focus, Cognito, I didn't want to focus on Cognito, but the main idea is that with Amplify, if you want to add additional components to application, like authentication, you don't need to do this manually. You see, you just add, you execute a command Amplify add auth, and it does it all for you, and then you commit the source code. So, now we are getting to the main piece. So what I'm doing right now is I'm opening DynamoDB console, and I will create a new table that will store all the requests for a write that were done by my customers. So I will call the table writes, and I need to define an index or partition key for this table. So what key I will be using for extracting the data from it. So yeah, some additional settings, will not speak much about them, just left everything as default. So it's creating, it will take just less than a minute, and I'm fast forwarding here again. The next thing that I'm going to do is I will create a role. Remember what I said about Lambda, you must have a role for your Lambda function to be executed. So now I'm selecting Lambda as my use case, and what I will do, I will add two things to my Lambda function. So one thing, I will add just the default Lambda execution policy. That's what I'm doing right now, and I actually had too many of them in my account, so I'll search it for a couple of seconds. So the basic Lambda execution policy allows Lambda to write the log files and create metrics. So that's important to monitor it. And then after I add it, I will also add another policy, an inline policy that I will create to allow my Lambda to speak to my DynamoDB database. Because by default, it cannot do this. It doesn't have enough permissions. And I'll now find my role. Click Add Permissions, create inline policy. And the inline policy, you can use JSON to create, to explain the policies, and you can use infrastructure as code. Of course, that's the best practice. But here, I've decided for the demo purposes to just do everything through the UI. So I select the service which I want to provide access to. I select the call put item. And then the system says, yes, you can create the policy, policy, but we recommend to limit it just to specific resources. So to provide access to create items, not in all DynamoDB tables in my account, but just to this specific one that I have created. Again, the best practice, keep your privileges as small as possible. And yeah, here I had the typo in the name, of course. So adding the policy, reviewing it, and create them. So let me, again, fast forward a bit, just to save some time. So the next thing that we are going to do is to create the actual Lambda function. So we are just moving from right to the left in the architecture diagram that I was showing previously. So in the Lambda function, you have here the basic information that I've explained. So you need to define the function name. You need to define the runtime. So as I've said, Node.js, Python, and so on. Oh, by the way, Sergey, you've seen it's Python 3.9. We discussed it yesterday. So, and then I select the role that is used for my function, so the one that I have just created. So advanced settings is not something we will need right now. That's like VPC access that I was mentioning previously. And then the next thing that we are going to do is we are going to create our function code. And I have prepared it in advance, so I've just pasted it. And what happens in this code, just to briefly explain you, so we have this exports handler. So this is the main handler of our function that will be called on the invocation. So we just check some context. We make sure that the authorization has been configured. Then we get the information from the event about the user who has requested the unicorn. So this is how you can get the information about the event. And then we also get the pickup location, so the coordinates of the user where we will send our unicorn. So then we have the function find unicorn. As this is a demo, it's just random. We randomly select one of the unicorns that we have in the system. And then another function that we have here is record write. And it speaks to DynamoDB table. And here you can see DDB put. It creates a new item in our DynamoDB table with information about the write and the coordinates of the user and the unicorn. So that's how it looks. You might remember in Andrei's presentation, you have seen this stuff about SDK, so I will not speak much about it. So now I've deployed the function and I want to test it. So testing for Lambda is available directly in the console. But as you remember, Lambda works based on events. So I need to create some test event to trigger my Lambda. And I pass the JSON here. JSON can be any. It's up to you. There is no limitation from Lambda side. In my case, you can see that there is pickup location for the user. There is information about the user. Pretty much it. So we save this event. Then we click the test button, and this should trigger our function. So here we get the output. So we were assigned a unicorn. We were sent some ride ID. We were sent the unicorn. And then we have ETA, estimated time of arrival, when this unicorn will be with us. And who is the rider, who is the user who has requested the unicorn. So now DynamoDB is ready, Lambda is ready. So the last part that we need to do is we need to configure API gateway. So you can see here two types of APIs, three types. REST API actually has two subtypes, REST and HTTP. The difference between them is in the cost and in the features. So you can either create a new API, use an example API just to play around with it, or upload your Swagger file, which is now called OpenAPI. So I will create it from scratch. And what I will do first is I will create an authorizer, because you might want to have public API, which is available to all the users. So create an authorizer is optional. I will use Cognito, but as I've said, you can use anything else. In this case, you will use Lambda as your authorizer. So it means that you will have two Lambda functions, one with the business logic, second for your authorization piece. And in my case, I will just tell that it's Cognito, so the only thing that I need to configure is the header, the HTTP header, where the token information from my authorized user, authenticated user is stored. So now, what I'm going to do next is I'm going to register, as I already have Cognito integrated. So we'll just type some username, password, email, and phone number. But of course, with Cognito, you can customize yourself what are the things you want to ask from your user. And in my case, I will be verifying the users based on email address, not by phone number. So I'm entering the code that I received by email. And then I'm logging into the system. So what will happen next is my front end actually has a configuration file. And it sees that I don't have any APIs yet. So it gives this warning that there is no API. But if you want to test just the authentication piece, here's the token. So what I do is I pass this token into API gateway, click test. And you can see this is the information that I will get in my real production system. So the username, the user email address, phone number, and so on. So as you can see, both with Lambda and API Gateway, you can do testing right away. You don't need to deploy it to do the test. And then the next thing, again, in production, you would probably use infrastructure as code, or you would use Swagger Open API format. But here, to show you how it looks like, I'm creating this manually. So I'm creating a new resource called write. I'm enabling CORS. So CORS is the way how your browser verifies that it can actually access this API. And as this API is accessed from the browser, we need to have it. So API Gateway does it for us. We don't need to think about it ourselves. And then we create a new method post. So for those of you who are familiar with REST, you know that post is usually the method to create a new resource. So in this case, I'm saying that I will integrate with Lambda function, but as I've said, you can integrate to pretty much anything in your system. And I'm selecting one of the Lambdas, just typing the name and selecting in the dropdown that I already have. And there is a warning that we need permissions. Remember, all services can only speak to each other with permissions explicitly assigned, but API Gateway asks us, do you want me to create permissions, or you will do it yourself? So I've clicked yes, do it for me, to avoid showing this piece once again. And then I assign the authorization to this specific method. As I've said, you can assign authorization to the whole API, but in this case, just for testing, I assign it here. The last thing to do is to deploy it. So you can have different stages. So you might want to have your development environment, staging environment, production environment. In this case, I treat it as directly production environment. So why it is important is you might have different cache and throttling settings in them. And here we have the invoke API. This is API that we will use in our Lambda function. So what I now do, and I understand that on the back rows it's hardly possible to see something, but there is a config.js file for my front end, and it has a parameter of the API URL. So I'm defining this parameter as the value that I received from API Gateway with this endpoint. And then I commit the changes to repository. So push them. And then I will return to Amplify to wait until my CI/CD pipeline finishes. Yeah, I've lost the tab with Amplify. So we'll refresh the page. And we'll go to hosting environments to see. So it's provisioning, again, fast forward until it is deployed. And here we go. So now I will switch to the application itself. I will refresh the page. And now we don't see any warning because we have the API defined. And we just click somewhere on the map. We click request unicorn. And here we go. We have the information about the unicorn that was assigned to us, and this unicorn is arriving. Then we click to a different place, request unicorn. You can see that's a different unicorn that is arriving to us. So that was it with the demo. So just for you to understand how much time and effort it takes in real life. So for me, this demo, like end-to-end creating it, has taken something about 1 hour, or maybe 1 hour and a half. This doesn't include code creation. And as you also understand, I was doing everything manually through the UI. So with the infrastructure as code, this would be much faster. So finally, the last 5 to 10 minutes of my presentation, I'll just speak about some of the other patterns you might want to think about. So first, event-driven. Why are Lambdas event-driven? Well, there are several reasons about this. First, you separate producers from consumers, and it allows you to introduce changes independently to them. So you don't need, like, if you change the interface of the consumer, you don't need to go to producer and change it. Another thing is that you can have your events asynchronous. And remember what I was telling previously about upstream systems, so you don't need to wait for the reply. And final important reason is that your microservices can have different levels of performance, can have different load on them. And it might happen that the downstream microservice has less performance than the upstream one. And in order to not overload it, with events you can actually have a buffer which will stay there until your function is ready to process them. In terms of invocation options, so the default one, the synchronous option, you just execute API, SDK, whatever you like, and you execute the Lambda function and wait for it to return the reply like I've shown in the demo. The asynchronous one is you use a different call. You trigger the Lambda function, but you don't wait for the reply. It just returns the response immediately to you, okay, everything is fine. And finally, the poll-based, and that's actually something I really like. Like, let's say we again have some streaming solution with the temperature coming in. And by default, when you work, for example, with Kafka, you need to poll new events from your stream. With Lambda, it's done for you, and your Lambda is only executed when there are some events in this queue. So what this, and by the way, you are only paying for Lambda invocation, so you're not paying for Lambda to poll these events. So this is done for you, and it's done with no cost. So I think that's a really cool feature. Now, one example of why event-driven architecture is important. Let's say we have an e-commerce website, quite simple, quite functional. So we have an order service. When a customer places an order, we want to trigger an invoice for them. Works great. But what happens if our website starts to grow and we want to add more microservices? Well, what this means is that our order service needs to know about all of them. But again, if we return back to my presentation, the whole idea of microservices was to decouple your application, and now we're creating this tight coupling. So what can we do? Well, we can use an event bus. So this is an icon of service called Amazon Event Bridge, and if you're familiar with enterprise architectures, that's something similar to event bus. So you get all the events here, and then they're filtered out to different microservices that need them. Like, for example, let's say we have the same order service and a new order has been placed. We will send a JSON, something like this. Again, it's up to you what fields you want to have in this JSON. In this case, it has the order ID, the ID of the member, the price, and so on. And then each microservice that is in your system creates its own filter in the event bridge side and only gets the events it is interested in. So let's say in our case, these 3 microservices are interested in new order events. So only them will get it. And this is how the filter can look like. So you can filter by any attribute of the JSON. And now what happens if we add a new service, let's say a loyalty service, and we only want it to know about the orders from the customers that are part of this loyalty system? Well, we can filter out by member ID, which is not null. And then your loyalty service will work, and order service doesn't even need to know about it. Then another thing that sometimes AWS users ask about is about Lambda architecture. So should we create one large Lambda function that does everything, or should we break it down into separate functions? And similar to monolith and microservices, we sometimes call it Lambda-lith architecture. So as you might imagine, based on my previous explanation, this is not a recommended pattern. So instead, we recommend that you create separate Lambda functions for different pieces of work. So usually we would recommend to create one Lambda function for a microservice. So don't go too small, don't create nano-services, because then it will create too many functions for you to take care of. Another question is, we can say, okay, that's great, Lambda scales really fast, everything is great, but what if I have a downstream system that cannot scale that fast, like relational database? So what do I do with that? Well, one solution can be is that if you speak specifically about databases, you can use some connection pooling. Like, for example, with Postgres, you can use PG Bouncer. In AWS, we also have a service for this. It's called Amazon RDS Proxy. Or some databases actually provide the possibility to speak to them not in SQL interface, but in the REST API interface that can scale better. So that's something you can use. If that's a different system, if it's not a database, then what you might want to do is to decouple Lambda from this system, for example, using the queues that I already mentioned. Or you might want to actually limit Lambda scaling. That's also possible. So you can say that I don't more than, for example, 100 instances of my Lambda to be running at the same time. Well, not the best solution, but still something you can do. And final pattern is waiting to wait. What if your Lambda function needs to make a call to another system, and this call takes a lot of time? So should we wait in our Lambda function, or what other options we have? Again, the answer is we shouldn't wait. The answer is the best would be your Lambda function kicks in the call to a downstream system, an asynchronous call, and finishes its execution. And then when the downstream system finishes processing, it creates a new event, and this new event triggers a new Lambda function. So this way you save the costs, and you make this architecture quite simple to understand. Another possible option that you can use if your workflow is more complicated, because you can see here it's just one system and 2 Lambda functions. If you have something that requires a complex orchestration, you can use a service called AWS Step Functions. It's a serverless service that allows you to build kind of workflows to manage some complex operations. Like, let's say, if you have machine learning, then what you might want to have is get some training data, train your machine learning model, then trigger some Lambda function to notify someone, then put this model into production, do something else, and so on. So that's kind of tasks you can orchestrate. And just one more tip here. As I've mentioned, Lambda is stateless, and it can happen that there is a new environment generated each time you call it. But in fact, we don't destroy your environment right after the function is executed. So it can happen that if you have a lot of calls coming to your system, that they are all using the same environment. And what this means is if you have any initialization, like for example, you need to initialize SDK or something like that, the best thing would be to initialize it outside of your handler. So, and this is actually an anti-pattern that I've put here. So the best would be if you put this client equals boto3 client above the handler. This way, if your Lambda function gets executed in the same environment, it will reuse it and will be faster to run, which will provide better experience to your user, and you will pay less for that. So you might remember in the demo, I've actually done this, that DDB equals, I've put it above my handler. Summary, some key takeaways. So first, serverless is not just compute. Hope I was able to demonstrate it with my presentation. Then there are some most common scenarios where we see our customers using serverless. That's both automating IT processes, microservices, and data processing. I would say actually you can use serverless for pretty much anything that is less than 15 minutes execution, but the most value you would get from the spiky workloads. So if your workload pattern changes during the day or even can change during the seconds or hours, then serverless is probably a good choice for you. But overall, we have customers who have built their complete applications, complete websites on serverless, so that's absolutely possible. By the way, if you know a Cloud Guru, which is online education portal, their website is fully serverless, even though I would say it's quite complicated. Then focus on business logic, so that's what serverless allows you to do. You don't need to think about maintenance. But still, serverless is not the same as regular instances. So it's not lift and shift. It requires you to adopt new architecture patterns, learn new architecture patterns, and just see how they work in your environment. So finally, just one link. Actually, I'm quite lucky because yesterday I was speaking at the meetup about gravitons, and I also had just 2 links. Today I have just 1 link. These are great services, so usually I have the whole set of links to share with additional information. But for serverless, we have this great website called serverlessland.com. And it has links to blog posts, to videos, to some best practices related to serverless, and even to some live events, both online and offline, where we'll speak about serverless. So if you're interested, please take a look there. And that's it from my side. So I will be open to the questions now. Unfortunately, I didn't manage to catch up on time, so I guess we have limited number of questions that we might have. So if you don't have time, you can either find myself here or just contact me on LinkedIn. Thank you.
Mike, 3 questions. Three questions.
I think this gentleman was the first one.
All right. Hi, Mike. I'm the guy who asked you about cybersecurity last evening, but today I'm going to make more specific question. Let's imagine I'm a startupper and I want to implement my project, which is going to be based on the microservice architecture on the backside, and I want to use a non-relational database. And what do you recommend, which AWS service is going to fit my project? And when I'm saying going to fit my project, going to fit the pure startupper project. Mm-hmm. So it's the most optimal version.
To be honest, like my first answer to you would be not use serverless, but yeah, if this is something that you must use, maybe there are some reasons like relations, or that's the most where the most expertise is. So yeah, that's fine to use it. I would say it's Aurora serverless. So I have quite large customers using it in production. So we have released version 2 of Aurora serverless just earlier this year, and it scales fast. So like within seconds, you can get to hundreds of thousands of connections from zero. So I would say even for serverless architecture patterns, it would work. And the good thing with Aurora, it's the service we have built specifically for the cloud. So we have separated the compute layer and the storage layer. They scale separately. That's why it's also good for this use case. And it has MySQL and Postgres interface compatibility, and it's really a full compatibility. So if you know Postgres, if you know MySQL, then you can use Aurora. So I'd say that's probably it. Thank you.
Okay.
I didn't see who was the first. Just pick up any of the hands.
Okay, let's go to...
Okay, Mike, hello. I really like your speech, but I have some specific question about the database. So let's say I have an existing project and there's a lot of database, and especially SQL database with a lot of relations, with a lot of tables, and I want to add some new service, some new microservice, and it has on the Amazon Web Service. So what do you recommend? Should I just fully migrate my existing project to serverless, or should I create some Lambda, some APIs to connect with each other?
To be honest, I would recommend approach similar to the approach how you break down your monolith into microservices, so you go piece by piece, because migrating the whole application, first of all, if you didn't work much with serverless before, it can be quite challenging to understand how much it will cost, because serverless is absolutely a different paradigm, and that's why it will take quite some efforts to estimate it. Secondly, as I've said, serverless is probably not always the best fit, so I'm not saying just move everything to serverless. So serverless is the best for spiky workloads, when you can re-architect your application this way. So I would say probably, let's say when you create a new service, try it with serverless. Then if it works, when you have time to, so if you see some value from it, if you see maybe your cost decreased or your performance is better, then you can start just breaking down the existing service and moving them to serverless. What you can do on the serverless land website, there must be links to the workshops, and one of these workshops is actually, well, that's slightly different use case than what you mentioned, but it's about breaking down the monolith into serverless functions. So you might want to take a look at that and see if those are the patterns that you might find helpful.
Okay.
So I think someone from this side was...
This side, okay.
Yeah, let's give the mic.
Hello, Mike. My question is about e-commerce. As you said, we can integrate AWS into e-commerce. So I will be a little bit more specific on e-commerce. Let's talk Shopify. So what's the advantage of AWS to integrate with Shopify? So I saw the slides where it has triggers, like adding the customer or updating customer events. So if you know, the Shopify has its app store, and there are a bunch of apps which can handle these events as well. So what the advantage of AWS upon them? So.
Yep. So to be honest, I'm not that much familiar with Shopify, but on a kind of a more high level, how to answer this. So first of all, AWS, it's not just about infrastructure. So we are absolutely fine with having SaaS solutions out there, and you might see it on our partners website that we have a lot of companies that we partner with that are actually providing SaaS solutions, like it is the case for Shopify. So it's not a competition, this or that. So it's more about the mix, about taking the best from both worlds. So I would say AWS main focus is on builders. So if you need to create something yourself, something from scratch based on your own requirements, which is not available in Shopify Marketplace, then you would probably want to go with serverless. And by the way, that's a great example where I think serverless would work, because if it's kind of just an extension of an existing system, you don't probably want to put some instances there and manage all this stuff. But overall, I would say AWS is not providing any kind of e-commerce solution, so just go ahead and use Shopify. And if you need to extend it, for example, by the way, with extensions, sometimes it might happen that you don't need to run them all the time. Maybe you have an extension that is executed, I don't know, once a month to generate some reports on the sales. So that's where serverless would be really great, because you will not be paying for the resources, but still can execute your custom logic. So just to bottom line, only the extensions piece, and only when it feeds this serverless functionality pattern, so execution based on the event, so when it's not available in the marketplace.
By the way, I'm sorry for interrupt you. We're running over time. You can ask your question after Mike finish. So, Mike, thank you very much, and let's say thank you for Mike.
My
question is, what's the best of the best question
Yeah, I wanted to say I like the question about services being moved to serverless.
Okay,
Yeah.
so you will get the AWS special T-shirt. Okay, let's say put hands together for that. Yep. So my question is, guys, are you tired and are you want to stand up and make some stretch or get the meal? So if you want it, so let's do this. And we have a break for 20 minutes, coffee break for till 13:50. And after that, we will have group photos. So don't forget to wear the Rolling Scope t-shirt. And don't forget about creating memes, getting photos with stands.
Dear guests, we have available places here, so you may sit down a bit closer to the presentation. So we have a couple of changes on our agenda. First of all, after Egor's presentation, we will have an opportunity to have a group photo. And after that, we will have a lunch time for 1 hour. The plov will be served for each of you. Yeah. And after lunchtime, we continue our agenda as it planned. Okay? Great. So, Egor, the stage is yours.
Yes, thank you very much. Hello. Hello, everybody. Thank you for having me today here. And I will go through the class for buzzword full stack developer and how we can make our lives easier with using Amplify Studio. So, but first of all, I would ask you a couple of questions. How many front-end developers here? So let's stretch. Okay. Yeah. Back-end developer. Back-end developer. Okay. Full stack developer. Full stack developer, yeah, I see you. And who work directly with designers? Designers. And maybe who live with designers, but not work. Yeah? Actually, hey. So yeah, so actually my wife also UX designer, so I'm not working with her, but I live with her. And I think Viktor, he also have a UX designer, and yeah, great. So we have a lot of iteration with designers, and let's start. So my name is Egor Miasnikov. I'm solution architect at AWS, and I work with the clients, as Mike said. He work in the different domains, so I work with the small and medium business, and I work with the countries. So currently, Uzbekistan is my country, and I work with the customers from Uzbekistan. And before that, I work a lot at EPAM and built the product there. And I started from the very beginning, from the middle software engineer till the chief software engineer. And I was, as Andrei, chief software engineer at EPAM. When I moved to Munich, and currently I'm in Munich and work at AWS. Okay, so today I'm going to tell you a story how we work from very beginning to production product development. And I would like to introduce our actors today. So we have designer. And we have front-end developer and back-end developer. So here I divided them, but we have a lot of full-stack developers who are one person who will do front-end and back-end in this case. And what expectation from beginning to the end of application development? So we have designers who are working with the customers or end users and prepare the mock-ups for front-end developers to create this great application. We have our front-end developer who are building from the mock-up all this front-end and iterate with the back-end developer to store the data, get the APIs for getting this data, and so on, right? And we have back-end developer. So backend developer create the services, databases, doing some stuff around infrastructure, and we have our users who are happy to use our application. So this is like ideal world where we use applications. And yeah, and in reality, we have the same. Actually, we have designers who are doing mockups, work with the our front-end developers and work with customers and end users and prepare mockups for our front-end developers. We have front-end developers who work with designers and back-end developer and create this front-end. We have also back-end developer, and back-end developer create the services for front-end. And we have a user, right? But our designer understand that we need to add the small feature for our application, and what we do, so we create the mockup, send it to front-end create the new version of UI, for example, or add in some feature, and work with the backend developer to add some APIs for getting data, right? But what if we are iterate? So designer wants to fix some components, so we iterate with designer, a lot of interaction, plus we have a backend developer where we need to data, and we said, hey, we need to fix that, we need new API, and so on. And we need changing our requirements and changing, right? But this is normal, actually, because we are living in agile world, and every time requirement changing, we doing the pivot of our products, and we need to align with the market. So developers spent a month to moving pixels from the, for example, buttons from 5th till 6 pixels, and repaint the color of the buttons and stuff like that. So let's dive deep what actually our designers do. I have a demo here. So let's imagine that we have a Figma. So who knows what is Figma is? Great. I see developers also know what is Figma is. That's great. So we have a Figma, and let's imagine that we have a huge file with the components and primitives where we have set up all the colors, all the small like buttons or switchers, and the huge one like components, right? And our designer think that we need to build the page where we are this is e-commerce page where we needs to be a top bar and the product cards where we sell our backpacks, right? So we are setting, so designer goes to grab some coffee, set and create mockup for front end. Currently, designer added top bar and currently putting the product cards on this side. So it's going to be 3 columns and 2 rows for, like example, for front end that we need such setup, right? Okay, so it's a little bit longer. So yeah, so we have number of columns, 2 rows, and yeah. So we're going to build this application today in our demo, so this is going to be interesting. In addition, we have 2 variants of our top bar in different sizes. From big size, we have like a title for our categories, and this, for small one, we have a burger menu. Who knows what is burger menu? Yeah, even backenders knows what is burger menu. Okay, but we just saw what our designers did, right? But 50% of designers not satisfied with the developers' implementation of their designs, right? And designers, in this case, are not happy. And developers frustrating. Who are frustrating with design? Yeah, very good. Only a couple of hands. And what if we have a tool to help you to move these components from design to the React? So who are writing on React? Even backenders write in React. Okay. we have Amplify Studio. And I have a couple of slides, actually. What is AWS, but Andrei covered it in deep details. So I just said that we have 200 plus services, and we have 28 regions, because a couple of days ago we just ran new region in Zurich. We have a core services like compute, storage, and networking, and specific analytics and machine learning. So if you plan to run analytics or machine learning, you can use specific services from our list of the services. And let's back to Amplify Studio. So Amplify Studio also one of our services in this case. And let's go to the demo, right? So we need to get, I'm start demo? No? Yeah. So we need to get our components from the Figma to put it to the Amplify Studio. What we need to do? So we need to get the share link from the Figma and put it inside the Amplify Studio, set continue, and that's all, actually. So this is easy, right? Currently we are, yes. So we see this splash screen where we sync, and we get all the colors and all the temps from the Figma, which are defined by designer, and all the sizes. So you can reuse it in the Amplify and React. And when we can apply it, and after that, we see our components. So we have like 30 components here from the Figma, and we can go through the one by one these components, but we can accept all and apply all to our library. And we see, if you can see that we use UI library as the basement for all our components. Yeah. So here we export components from the Figma, and for example, here's our card and splash screens and so on. All right. So just to recap. So we just see how designer create the components, right? From our side, as a developer, we just go to Amplify Studio, get the link from the designer from the Slack, for example, get this link, put it, and we have all components here, right, from the designer without any coding, right? So you like it? Oh, you don't like it? Why? All right. And you can say, hey, there's so much to build the application, right? And you're right, actually. So evolution of front-end is huge from the 8th of 19th. We have JavaScript, and currently we moved to the serverless and 2015. And now we have our first site at Amazon.com. It's just a static site with the links. And now we use Spotify, for example, where you see that many applications work as native applications inside your browser. And Fullstack, yeah, so let's say a couple of words around Fullstack. So Fullstack, this is people who are starting from HTML and finishing databases. And in a couple of things we can help you. For example, for API, from server side, serverless, and so on. So you know that around the serverless and database also can be serverless, as mentioned from Mike's presentation. And we built Amplify to make your as front-enders life easier, and I think full stacks life easier as well, because they are also faced with the problems with backend side. And let's see what is Amplify. So in Amplify, we defined a couple of stages. So we have a build. So we need to build our application, ship, and scale. For build, we have UI components. So I use predefined UI components from simple library from AWS, but you can use your own and prepare the AWS backend for that. For shipping, we deploy application directly at AWS, and it helps you to, using one command, ship your application to the cloud. And scale, and when you are moving it in the cloud, it's going to be scaled because we are using our best practices to scale application in the cloud. And for Amplify, you can make faster because you are predefined, you have predefined components, libraries, and pre-built backend code. You can just focus on innovation rather than on the writing code, because writing code is just around the coding. But if you are building an application for your customers, you need to do some experimentation, innovate new interfaces for them, and you don't need to focus on the coding. And scale. So we are using our cloud for scaling, and you can, using Amplify, you can scale global. And we have theming, UI primitives, and cloud connections. For example, we can use Cognito for connecting signups via Facebook, for example. And let's go to the demo. So here we are going to see how we integrate our code, our template to the code, right? So currently we have components in Amplify Studio, but we work as the React developers with the code, and let's see how we, yes. So first of all, we need to go to the components and see that how we can integrate it. So for integration, first of all, we need to integrate Amplify in our React app. For it, we go to, so I get this simple React application, create React app, right? So, and going to integrate Amplify in it. I set up Amplify library to my node dependencies and put the code directly from Amplify to my React app. It's a little bit slower, but I think next demo's going to be more faster. Yeah, so we import a lot of things from the library, do configuration, and do theming wrapper for our application. Who did this every time when set up the project? What? When you set up new React app and trying to integrate all these libraries, stuff like that. Yeah, so yeah, we need to optimize it, right? So not to do it every time. And yeah, so we are using a theme provider for integrating our library to React app, and after we get the top navbar and putting in our application. I think we can, yes. So this is updating. So we need, every time when we do some changing in our application, in our Amplify Studio, we need to do Amplify pull, because we do it in our studio and we need to get the change data to our local environment. This is like in GitHub, for example. And yeah, you see that we have just create React app application, and I'm going to go to app.js, and here we are remove all the code and enter our navbar, right? Navbar, so yes. So we get all the code, the snippets of the code prepared for you in Amplify Studio, and you can just copy and paste here. So yeah, copy and paste developer. Yes, so we integrate it. So we import our UI components and enter it to our application. And voila, we get it inside our application instead of the splash screen from the React, right? But you see, this is only one variant, so it's currently not flexible enough, and we need to add flexibility for our application. And as you remember, we have two variants for top navbar, where you have like large size, where you have all these categories on the top bar, and for the small bar, we have a burger menu. Burger menu? Yeah, you know that. So we need to use we need to use breakpoints and understand what breakpoints currently in the window, and use variants for our top navbar for understand what kind of components you need to do. So in this case, it's great that you are not implementing all this stuff by yourself. It's migrating from the Figma directly to your application. It's a cool, right? Cool? Ah, many arms. Okay. All right, but our designer decided to change UI a little bit, and we just implement our top navbar, but designers say, our customers don't like that. They have this nice icon with the photo on the top right, and they want to remove it. And what we're going to do? So let's watch the demo. So as you see, we have a top navbar, and top right, we have an icon with me, right? So this is like my old photo there. Yeah, I'm not starting the presentation. Yeah. So we have old version of top navbar, right? And what do you think? How we going to fix it? Remove from the code? From the Figma? Oh, come on, program Figma. Yeah. Yes. Ah, spoiler. All right. So we have two variants, right? And what we need to do, so our designers goes there and say, I don't need that, so I need to remove it. So designers goes and remove it. And say, hey, our developer, front-end developer, I removed just this photo, so please remove it there. What do you need to do for that? You need to go to Amplify Studio and go to our UI library and press Sync with Figma, right? Sync with Figma. And what happened? What happens? And what happens? Happens. Magic happens. Magic happens, yeah. So we have like a current version and new one. For current version, we have my photo. For the old one, we don't have it, right? And we need to integrate it for our UI, right? For our React app. For our integration for our React app, yes. So we update it. And okay. We need to do amplify pool. Yes, so we are doing amplify pool and restart our server. And what we got that, voila, we don't have it. So our components updated without any code. This is cool? Cool? Yeah, cool. Okay. All right. So, but this is like only static application, right? So this is not there is no any difference between what I show you today, like Amazon.com and 90s, where you have a static site with all these links. So we need to do some optimization and do more functionality. And for functionality, let's set up authorization. And do some modeling, so we need to get data from that. And maybe filtering, right, for our product. And all these connected UIs. So how long do you think it's going to take? 10 days. 1 month. 1 year. So to do all this list, 1 year. Yeah, you're okay. 1 day. Yeah. If we get a couple of meetings with backend guys and designers, so it's take 5 minutes and all day meetings, right? So let's see the demo. But before that, I would like to show you what Amplify Studio is and what we have here. Yes. 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 So we have main screen. Here you have all logs, what you do on Amplify Studio. For example, you are deploying something. Deploying services which are related to Amplify Studio, deploying your application, and you have deployment activity here. For example, you see that I deploy in staging and a couple of services related to that. We have content. Content, this is our database, actually, and this content related to DynamicDB, and you see in the simplest list that you have in different models. For example, I have models with the products, so I prepare it for you, and I have users. So I users not using, but this my old photo actually from this model. And for the model, you can edit or create new ones. Currently, we have title, description, image, action, maybe buy or pre-order, and we have price for that. And we have user management. We need to do authorization for that, and we are going to prepare authorization for the users. Currently, we don't have any users. This is nice because you need to know about your user when you try to sell the products. Maybe for working with the current orders or any other statistics. We have authorization, so for authorization we use Cognito. So Cognito nice to manage our users in AWS. And yes, so we are in the GraphQL. So for API, we use GraphQL, and you see that Amplify Studio set up GraphQL schema for me. So I'm not touching any schemas there. So I just put the model in the content, and that's all. All right. That's it, yeah. So we have our site, and we need to add authorization. For authorization, 1 day, right? 1 day, yeah. So four guys, 1 day. Let's see how it's going to work. For authorization, we need to go to our user management and set up the user. If you know what user is, you can set up for him account. I put my email and password, and I go to my code. I go to my code, right? I go to my code and add one wrapper, right? I'm adding wrapper for use authorization. And after that, I just wrap application. We rebuilt our server, and we have authorization in our app, right? So first, actually we have authorization in our app and sign up as well, so your user can go on your site and set up account they own. So currently I add my credential there, and because of I set up manually this credential, authorization asked me to set up password because of admin knows my password. And voila, we have authorization. All right, so how we can add sign up now? So we are just authorized user, and user in secure space currently, but how user can sign out from this secure place. 1 day, how many? 1 day, yeah, 1 day. 2 days? All right. So this is interesting point. So we are going to Amplify Studio, and Amplify Studio can map your components on the model, and it can create the functionality for you. So we are going to go to our components top navbar, choose the icon for sign out, and choose the sign out from this device. For frontend, we need just to amplify pool and restart our server, and it works magically. It works? Yes. So currently we are restart our server, and if we click on the right bottom, we are sign out. It's a cool? Okay. I just save you 2 days currently. All right. So this is not it. So we have like a basic functionality, and we need to add our product card, right? So we are building our shop, and we need to add product card. So we use action card, I think, yeah. So we use action card, and interesting thing that we have a model with all the data which we are storing in the DynamoDB, and we just start in mapping this model with our component. For example, we have like image, and we say that, hey, this image and source get from this product model. We have title, for title get this title from this model. The same for this description, same for price, and same for action button. And this is like data-driven development, I think. When you have data, and this data help you to build the components, right? All right. Do you think that it's easier for designers? Yeah, so designers, yeah, so it can be. Yeah, so we need question, yes. All right. I have actually I have one question here. Okay, so you see that we are getting all a product card, and we need to build this grid. So how long does it take to get these components and build such grid? 2 days, 1 week, 1 day, wow, guys, you're so performant. 1 day for each task. Okay, so approximate estimation for the site developer is like 3 days for website, right? I think. Okay. All right. So we need to build this. Oh, sorry. I moved to. Yes. So we currently here, and all right. So we need to build this grid. We have like 1 component. We just fill it with our model, with our product model, and we have all the data array. And what we need to do, create collection, and that's all. In collection, you can choose grid or line view, choose how many columns you need, and for example, we need 3. And here we also have built-in pagination and search, right? It's cool. Cool search? Yeah, so you just put the title of your product and you get this product, right? And how we need to integrate it? Who knows how we need to integrate it? Amplify pool, you're right. So we need to do amplify pool. And so we do an amplify pool. And we need to create add these components directly in our React app, right? Because we don't have it yet in our code. Yes, so we still need any codings, some codings here. Okay. So yeah, we updated here, and we have our top bar. We are adding grid. Grid help us do it more flexible. Also, we have view. Grid help us build the layout of our page. So currently we have 3 columns, 1 column, 1 fraction, 2 fractions, and 1 fraction. And for our view, we are going to start from the 2nd column, right? And we just add our action card collection into the view. And yeah, and view starts from the 2nd, right? From the 2nd column. And voila, we have here our website with integrated search and pagination. For example, we are searching and using our GraphQL and MongoDB, we are searching it easily without any adding codings, right? We just put 1 component in our code. All right, so we need to ship it. And currently ship it, it's also easiest part. So what do you think what we need to do? Who knows? Who knows? Yeah. Actually, when I prepare, so guys said that amplify push. Actually, when I prepare this demo, I also think that it's amplify push, but not. This is amplify publish. Yeah. So this is like a different naming. Yes. So for the demo, we already have it. So we need to build the asset. So build production asset and. Sorry. Yes. So we have this code here, and in terminal, I'm going to run. Yes. We need to add hosting. For hosting, we can choose hosting from Amplify or Cloud Frontend S3. So we are going to take hosting from Amplify. Is provide you the address, and we choose manual deployment because we can deploy by matching with the master branch, for example, for GitHub. So you push your code in GitHub, and it's automatically CI/CD process for pushing your changes to the production. Yeah. Currently, it helps us to set up all these things for setting the infrastructure. And you can see inside the amplifier that your progress, for example, for frontend, it's not starting yet, but from backend, it's already started. Prepare your services for your application. Okay. This is our staging. So you also create. You also inside the application. Amplify, you can create different stages for your application. Currently at staging. Staging is the default, and you can create production and, for example, build and publish for production first, and after build for staging, and after for production. All right. So currently I show you, yeah, so currently when it's deploying, I show you our DynamoDB models. And this is how it works, so you can see metrics inside the DynamoDB and see our models which are restored. So creating, optimizing build, so we are pushing it in S3, zipping, deploying to Amplify console. And we get the URL for that. So currently pushing, but we already have URL. You can click it and you have a working environment in the cloud without any setup in infrastructure code. And it works. So let me to sign in there. All right. Yeah, so it's work as expected, like on your local machine. And how we scale it? Actually, you already production ready because you have all this stuff from the development. You have primitives, you have your mockups, and you can reuse our Figma primitives for building your application. It's like Bootstrap, I think. So who used Bootstrap? Ah, how many? So you need to use the Figma, our Figma. Actually, well, you have UI primitives, you have customized components, and all things that you need to build application. For generated components, you can map it directly with your model. You create model and you map it. So we just saw it with our backpacks, right? You can create the handlers. You can create it in UI, in application Amplify Studio, and you can create it right in your code if you like coding, for example. And Amplify currently, it's a good for self-managed services because you can use CDK for create your infrastructure, and we know already what is CDK. And this is like backend as service offering because many of products use the same approach. I don't know what specific services, but they help you build backend services for you. And what you can do with backend. So for backend, you can use Amplify override to create your own infrastructure. You can add custom CDK, for example, or CloudFormation, or you can export your Amplify application as CDK. And say goodbye for state in application development process. So let's everybody raise your hand and say goodbye. Yeah, goodbye. Thank you. Thank you. So yeah, so if you want to try it amplify.aws. So my name is Egor Miasnikov. Thank you to be here. And please use this QR code to send me feedback. And this presentation can be better if you put some notes there. Thank you very much.
And time for questions. I saw the hand. We have about 5-7 minutes.
Okay, hi Igor. I'm a student in the YUT, in the Westminster University. So I have an argue with you because you know Amplify Studio is like a no-code or low-code tool. Yes, I think.
Minimal
yeah,
code.
Yeah. Because I'm a React developer, so it is like, you know, when you start your journey as a developer, you shouldn't use like Amplify Studio because low code. You should think about what is going on in the building your app, a front app, or like backend services, a process. You know, when you don't know about the process of building your UI or like, you know, components with building a React, without building a JavaScript or just building with Amplify, it will, you know, be a disadvantage for beginners, junior developers. So I don't know. Does it work to use like Amplify Studio to build like big scale app, your web application web, like it has like million users? So does it cover your app to build like full stack app and to maintain your coding and your application?
So thank you for the question. Actually, I just described the common product development cycle, right? So you have like designer who are built this thing in Figma, for example. You have your team of front-end developers who are getting this designer and build the front-end, right? You have a team of back-end developers who are preparing APIs for front-end, databases, all this stuff around infrastructure and putting on the cloud. Currently, you are startup, right? So, and you, the one you have idea. How help people, for example, you have great idea to build the startup, and what you need to do. You need to go deeper into infrastructure, CDK, for example, all this stuff around the back-end, front-end design, but you are a designer maybe, or front-end developer, right? So you need to drill down there, or you want to build the application which help people. So you want to help people, so you go to Amplify, set up it, and run. So if your application run, you can rethink how your infrastructure works, what optimization you need to do on the back end, how you need to optimize your front end. But in early stage, Amplify is nice choose for fast running in the production to show it to investors, for example, or other people, right? And test it. Maybe your idea is not ready enough, and you need to think about the pivot of your application, but of your idea, for example. But you are spent a month for building application just for testing, right? But you can do that in the 1 hour, for example, using ready design components. You are building all these components in front end, and you don't think about the back end because it's work, just work. And after, when you are going in production, you can get infrastructure to CloudFormation or CDK and get the team of DevOps and say, hey, this infrastructure I have, what I need to optimize, and that's all. But actually, we are using our best practices for building the backend application within AWS Cloud, and these help you to follow the best practices like in the box, because we are doing it for you, actually. But it's worth it, but if you want to, you can try it. And if you see that it's not enough for you for building application, you can just get the code of infrastructure, code of backend, and set up it by your own. Yeah. Oh, how many questions?
Hello, Egor. I'm a React developer, and I was impressed by how much we can decrease development time. And I assume that there is a trade-off. I mean, we decrease the development time, but we might kind of, ignore the maybe performance issues. So can you kind of be honest and tell us if there are some disadvantages of using Amplify Studio? Because at the end of the day, if we just switch to Amplify Studio, and it seems like we are doing unnecessary work, so there must be some minuses, of course.
All right. Yeah, so thank you. So actually, one of the clients asked me what he needs to choose between API gateway to use REST API for mobile application and front end, and AppSync. AppSync service, it's our GraphQL service, right? Who knows GraphQL? All right, so you use it? Okay. You like it? Okay, yes, and actually, you can get front-end, CloudFront and S3 to host your front-end and static file. You can choose one of the services, API Gateway or AppSync, for choosing API layer for getting data to your mobile or front-end. And you can choose database, right, for storing all this stuff. And currently, we are doing it for you, actually. So on the hood, under the hood, we are using front end, and you maybe see that I choose
hosting from Amplify, but you can choose CloudFormation and S3 for storing the static files. We choose AppSync for you because we are pushing GraphQL here in Amplify to run your application. And we are choosing a DynamoDB for storing your data. And this is like general architecture for web application, right? So if you are going to AWS, you are choosing between relational and non-relational database, for example. You choose the service for API or build your own, for example, on engines. But you still have this amount of services. And here we have like serverless service as AppSync to get all these millions amount requests for the backend, and the handlers for Amplify. We use lambdas for getting all this and handling all these requests, and we are have DynamoDB for storing and get back your data on the front end. So in this case, this is like typical, highly available and scalable solution for web application in this case. And if you are not like, for example, structure of the data inside the Dynamo, so you can choose between databases, but currently by default we are providing DynamoDB in this case. And this is interesting because you can try it, and when you are grow, you see the pain points of different services. For example, AppSync, you don't like it, you need to do something on the go and create it as a separate service by your own and support it, because all our managed services are not supporting your very high throughput of the users, for example. But for the start, this is, I think it's a very good solution for web application, and it's already scaled and ready for scale. Yeah, okay.
So I think it was the last question. If you have any other question, you may find Mike during our lunch time, since we have just 5 minutes left.
Egor.
I'm sorry, Egor.
And Mike, you also can find Mike and
Mike and other speakers as well. I'm sorry.
And actually, we have for you. I provide the T-shirt and the person who are. Okay. So yeah, thank you very much. And yeah, so we have plov and question.
But very important step we need to make, a group photo. So I invite each and every one of you here and have it together. So after that we will have lunch for 1 hour. And
quick reminder that we don't forget about contest, ma'am, and get T-shirt with stand up. And also don't forget that at the end of this meetup, we have the final contest, Kahoot, where you will be able to win electroscooter. I said it in Russian, electroscooter. How to say it in English? Electro scooter. Yeah. Okay, yeah. Okay, so, by the way, about the speaker, our speaker, Ivan, he's a software engineering team leader, and I met him when he conducted for me technical interview, actually. So, his speech called Fun with Micro Frontend. So let's put hands together and say hi for Ivan.
Yeah, hi everyone. So I hope it worked well. Yes, now better. Okay, so first of all, thank you for invitation to such great event. It's first offline event for me since 2019. Yes, for a lot of us. And today we will talk about fun with micro frontend. It's not some ideal micro frontend. It's not best practices, not tutorial. It's just story about our project. And previous speaker Egor and the next speaker Viktor. It's my teammates from this project. Yeah, it's a bit surprised now they are in Amazon. I'm still in EPAM and hope we'll continue. Yeah, and also Das. And at the last my slide, I will introduce one more. My teammates who helped me to build micro frontend, and I hope you had a good lunch. Yeah, plov was very great, and now we will discuss a bit micro frontend. Okay, who I am? I'm Ivan Fediaev, as you know, and I'm a software engineering team leader in EPAM, and in EPAM I'm also JavaScript Competency Center Ambassador, SMT head and expert, technical Czech country head, and my first meet was on technical interview, of course. And also I JavaScript lead developer growth program coordinator. And from NotIPAM, I was a teacher in university around 5 years. It was since 2015, just after my own graduated, and I read a lot of lectures about web development. And my hobbies, it's travel first of all, and I like drone photo video, but unfortunately in Uzbekistan it's protected. Okay, so about today's speech, about target audience. If you haven't heard but doesn't use it, micro frontend, yeah, it's for you. And also, if you ask your question why use a micro frontend, it's also for you. And if you just wanted to know how others do it, it's also for you. Okay, but first let's talk a bit about context of our project. Yeah, we joined to our client, and our client says that he has around 60 projects in backlog, and we need to implement one by one. He has a common design. It means that some common layout, common navigation, and other elements. Common authorization, we use Firebase for it, and GCP, and he needs some application factory. It means that we should implement application as soon as possible, one by one, yeah, just like a factory. and have some independent release for each application. And of course, it should be simple as much as possible. We shouldn't use some difficult technologies because the local developers from customer has not so high experience, and it will be better to use some simple ways. And how do you think? What would you recommend for this case? No. Yeah, Egor were in our project, but he also didn't know about Amplify Studio before. If no, we implemented it, and 60 days, 60 project. Yeah, 1 day per project. Someone say micro frontend, right? But not. We decided to use a more easier way and implement starter kit. It's more easier. We select Angular as main framework because we studied local market and understood that they don't have React.js developers. It was a surprise for us. And also we had a lot of experience with Angular previously, and customer team has experience with Angular too. And as you know, and also, who knows Angular? Oh, a lot of people, usually less. Usually everyone from React.js. Okay, and we just take Angular CLI and customize it a bit and create starter kit. It was a faster implementation for us. Also, Angular has a lot of limitations for developers, and you will write code only in one way, not like in React.js. In React.js, you need really great experience in architecture. You need some code quality gates. In Angular, not so much. And it's easy to use. But Angular has only one disadvantage, is learn curve. Yeah, it's a bit higher than in React.js. Yeah, and also our starter kit includes common layout, includes common authorization, authentication, using one framework, yeah, for all apps, and everything was great. Yeah, but it was difficult to update layout. Yeah, because if you implemented one or two application, it's okay, you just change code in 2 places. But if you have 60 projects, it's not so easy. And we implemented around 20 plus applications for 1.5 years, not only our team. Our team implement around 4 or 5. Other vendors also use our starter kit and implemented applications. And we faced it with one problem. It was first problem, that in all applications we use some tables, some graphs, some some other components, buttons, and so on, model pop-ups, and we decided that we should to move it to UIKit. And it's good solution. Usually we use UIKit in a lot of projects, but we face it with second problem. It's COVID, and it was a surprise for all world. And for us, it was ramped down. Developers decreased from 5 front-end developers to 2 front-end developers, and projects only for 1. And when you have a lot of tasks, but not a lot of developers, you can't implement something like UIKit because you have you need to implement a lot of functionality, and it's a bit expensive for you. And we freeze UIKit. Okay, and third problem is UI changes. Sorry, time to time I will drink a tea because I had a flu a bit time ago, and if I don't do it, we will have macro Koch, not micro frontend. Okay, and also another problem is changes in UI. Time to time designers change it, and Egor demonstrated in on previous speech. And also we had some other issues like adding new common functionality, notification panel, search engine, and so on. And our layout became changes. But as I said before, we already had 20 applications with common design, with common layout, with our starter kit. Yeah, and we add search panel, we add notification panel, and here we decided that we should use another approach. We should use not just front-end, we should use micro front-end. What does it mean? It means that we will have a separate application for separate part of our application. For example, we had a layout, and it's one application, and we can just change our layout without deploying other 20 applications. Yeah, it's one of the advantage of micro front-end. Yeah, and we decided to think how we can do it. We have several options, iframes, single SPA, Angular elements, and model federation. And let's talk about iframe a bit. Yeah, and if we talk about advantages, yeah, it's really easy. We just can use iframe. Maybe someone else remember some website which use some social network for commenting and left some feedback. And you just see iframe like a part of application. I think it was first micro front-end, but we don't know about it before and don't use such term. And it's support for all major JavaScript frameworks, and it depends on framework. Yeah, but it has some issues like how to implement deep linking and how to implement responsive web design. The main problem for us, because for each changes of browser window, for changing size of element, we should re-render this component, but we have a bit responsive design on our application, and this way it's not for us. About single SPA. For single SPA we have a POC, and thus implemented it, and maybe before or later he will talk about it, and we will have speech about single SPA. But for us it also was increasing complexity of our project. Yeah, but as I said on the beginning, one of the point which customer say it should be simplest as much as possible. And the advantages of single SPA, yeah, it's supporting lazy loading. It's integrated with I think all frameworks like React.js, Vue.js, and Angular, of course, and other one. But for that time it was not well documented. Now I visited this page, and it's really documented, has some tutorials, and you can use it without any problems. Yeah, but as I said, it's increased complexity, and for us it was bad news. Okay, we move to Angular elements. Who are familiar with custom elements? Okay, let's rephrase. With web components, or a bit more. Okay, great. And Angular element, it's just the Angular implementation of web components, and we can easily switch our Angular component to web component. And in simple words, we can just use our Angular components like simple components like div, span, form, text area, and etc. And here you can see just some schematic how it works in Angular. Yeah, use some method create custom element, pass your element, pass some dependencies to this element. Usually it's just an injector, and then you will have defined custom element on your browser. Yes, I said we use create custom element, implement our layout separately, pass it to this function, and have custom elements, layout up. It was separate application, and then we face it with problem how we will communicate with it, and how we can add it to our application. For our application, we can add it in simple way. We just use script and write address for this script. It's easily. And then we just use method when defined and wait while our component will be defined and just append child by renderer from Angular. And that's all. We have micro frontend now. Yeah, we have separated layout, which build it separately, which release it separately, and just take our code from link by SRC in script. Yeah, but it looks a bit ugly and not so good. Then we face it with issue how we can organize communication between components. Yeah, and it's also easier. If you use web component, we can do it by attributes. Like in Angular and React, we can use props. Yeah, the same with web components. We just pass all needed props. If you talk about some events and some communication from our component to outside, we just use listeners. You can use add event listeners, but as we use Angular, we use renderer listener. Okay, and from this solution, what we had? We have, first of all, it was framework agnostic, yeah, and it's use HTML standard, because you can use web component and or custom component in all browsers and without any things. And also it's easy to share and reuse. It doesn't have complex dependencies because when you use create custom component and then export only custom element, you don't export Angular or React or some other frameworks, and when you include it to your project, you don't have additional dependencies. And if you use React on your application, but your custom components written by Angular, it doesn't matter. You just import only a custom element. You don't load Angular additionally. If you talk about single SPA, in this case, you should upload Angular and upload React.js, and it costs some performance. About disadvantages, it's loading time. It's about CO, but for us it's not problem because we implemented some internal product. Yeah, it's not some public websites. It's just corporative system. And what about style sharing between components? Yes, it's problem, but also if you work it with Angular, you know that Angular use encapsulation, yeah, and Angular try to avoid sharing some styles between components. Yeah, and in this case, we also don't see to it like a disadvantage. Okay, and about Angular elements, we applied and we really like it, but we don't like way how we introduce our layout to projects. Yeah, because using links it's not so good because you have a lot of environments, dev, QA, UIT, production environment, and it needed to change. You can't do it by hard code. And we decided to use model federation from Webpack 5. And which advantages it gives us? First of all, it's sharing code. It's also framework agnostic, like in the previous solution. But for us, it also doesn't matter because we already use Angular elements and doesn't depend on frameworks. And it's have some feature architecture, yeah, and it helps us to build our application. Each our application is separate feature, independent, and it's work with any JavaScript. Okay, how it works? Usually you have some model federation plugin. You can define your application name, file name, also remote resource, share some dependencies and so on. Yeah, and we can talk about it a lot, and we can do separate speech about it. Yeah, but we developers, we are lazy. And as Egor said, we can just implemented some application from Figma, yeah, and why we should write a lot of code. Yeah, and for model federation, we have a lot of libraries for each framework. Yeah, and for Angular, we also have special dependencies which we installed and use just wrapper, which have only one option. It's some option with remote entry, remote names, exposed models, and element name. And we just pass all our properties to this configuration, and whoa, it's work. And only one thing that we should resolve, it's we have a lot of environments, at least 4. And we decided to keep our configuration inside secret manager of GCP. And for each environment, we have configured secret manager with our config for remote entry and other things. And okay, we applied 2 options from 4. We applied Angular elements and model federation. And what do we have now? Now we have layout as a separate application. We can build it without, and we shouldn't deploy all other applications if we have some changes in our layout. We just do it once time and see it in all our applications. Currently, we applied it only for 5 applications from 20, but I hope we finish other one in near time. And what conclusions have we drawn from it? First of all, that reusability, it's some good benefit, but it's not a target. The target was its independent deployment, each of application, because if we use a previous option with a common started kit, we should do changes in 20 projects just for adding one button, one notification panel. Now it's do it easily for only for one project. And also we are so lazy that we hosted our layout with our common application. We don't create some separate server. Maybe it's bad, but for us it's great because it doesn't increase count of our servers and so on, and doesn't affect our infrastructure. And also, you should implement your micro front end around some business features. For example, some panel some tables, some I don't know, pop-ups and so on. It shouldn't be about some large functionality, only by small features. And now we are working on splitting. We are going to work on splitting this functionality because some of our project asked us not about using whole layout. They would like only one search engine, for example, or only one notification panel. Yeah, and it's place for next improvements for our work. And also don't force this micro front-end approach just because it's popular, just because it's new. It's not good way. Yeah, you need to use it only if necessary. Yeah, if you have such problem and if you face it with it. Yeah, like in my speech. And don't introduce multiple JavaScript frameworks just to leverage micro front-end. It's great when you know a lot of frameworks because yeah, sometimes you became some framework agnostic developer, just engineer, not Angular developer, not React developer. I don't understand such positions. Yeah, and for me, engineer, it's person who just sit and write code in different frameworks and different technologies. Yeah, and you don't introduce a lot of frameworks to application to introduce micro front-end. Okay, our next steps. First of all, it's, as I said before, it's have a more micro front-ends. We will split our application more and more for some small parts and do releases independently and more faster. And also another thing, it's maybe monorepo. Because now we have only two projects in our repository, two applications, but if you will do splitting to some small features, small applications, yeah, it should be implemented. And maybe next speech from our team will be about NX. Yeah, and I think my speech a bit quiet and a bit faster finishing. And I would like to say many thanks my teammates. First of all, it's Das. Yeah, and another person, it's Jam. Yeah, and I a bit surprised that I do it so fast. But you will have more time for questions and for discussion, yeah.
Hello again. Thank you for your great speech. Well, my question is about like what types of companies most use micro frontends, and can you name a few the most like popular companies in the world? Like they often use micro frontends.
Popular companies who used it. Oh. I don't know, I think currently a lot of companies use it because it's really popular, and in my mind only some Russian companies like Tinkoff, like Yandex, yeah, and they use a lot of micro frontends because they have a really large search engine and banking system and need to release their features as much as possible and so fast as possible. And they have a separated team for each part of application. If you use some Yandex search engine, for example, you can see some search result, you can see some ads, some banners and so on, and all of them, it's a separated application. Yeah, independent. And also, as I know, currently Yandex implemented some new video player, and it's also separated application. And if you search some tutorials, some videos, and so on, it will be like a bit similar with YouTube, but it's Yandex video player at independent micro frontend.
Hello. My question is, did you consider any other ways of implementing this micro frontend architecture? I mean, other ways compared to module federation?
Other ways instead of model federation?
Yes, yes.
Like single SPA.
So these are the two only possible ways? These are the only two possible ways of implementing this architecture?
We saw to these ways. Also, as I said, the simplest way it's using iframe, just iframe. Yeah, but in this case, you should have responsive design. Yeah, but it's possible to implement. Also, you can use, I think, just a pure JavaScript and just the custom elements, as I said, without model federation.
Yeah, hello, my name is Mikhail. Just want to ask you, how do you connect all your micro frontends modules to one file? I just want to get clear if it's just only at Webpack connects, or it just connects like through their own NPM like packages, and you connect through all of them. I just want to get clear, and after that I got one more.
Yeah, we use only model federation Webpack. We thought about using NPM packages, but in this case, you also need to redeploy all applications if you update some library. Yeah, because you update, you need to update version in package.json, and you need to redeploy each application, but it's time, it's money.
Yeah, okay. I mean, like, just in my company, we use like exactly this way. We are updating from packages on. We've got our own NPM packages, and we do it like this way. And I mean, like, micro frontend, it's a really great idea. And I just want to get more information about your question about which companies which companies uses. I mean, like, one of the banks, like Tinkoff, but I work at another bank. We use it just because we've got so much different teams, and we've got our own business, and we don't need to connect like only one date to the end of the sprint, like to release all the systems. We can release wherever we want. Our things, our sprint's done, we release this, and this thing. Thank you so much.
Yeah, thank you, Mikhail.
Well, and the last question is?
Hello, my question related to web components. So, as you listed the drawbacks and advantages of the web components, so what if the entire project is done by only focusing on web components? So, will it be against the statement of not creating the framework? And because in our company, we are using web components for general things, not entirely, like for accordions, for sliders, for this kind of elements, but not entirely. So, and about the CEO, it's good for TEO as well, because with the extra attributes, we can like define the role of the web component. So, question is it will it be considered as good or best practice to do everything with web components? So in this case, everything will be like component based.
So it's, I think, interesting question. I can say that it's best way to use only custom elements. Yeah, but it's, I think it's wholly war question. Yeah. Because I know projects who use only web components, and it's really large projects with really large companies. But as from my side, I think no, because it's really to implement some shared state between these components. And if we talk about some complex applications, you will have state. And I don't know, in case of web components, you will have a lot of some event listeners also, yeah, and some passing some props inside these components and some prop drilling, and so on. Okay.
So, no questions for now? A couple of, okay. Since we have a bit more time, we will give you a chance to ask it. It's okay.
Can you please elaborate on service discovery? How you made it one micro frontend to discover another?
Sorry, could you repeat?
On service discovery, you know how one micro frontend locates another?
How communicate or how?
No, how they locate one another. Where you've said that you store it somewhere in a secret vault or something.
I'm not sure that I understood your question.
Окей. Просто как вы храните ссылки на микрофронтенды, чтобы один не находил другой?
About it, yeah, we have a secret manager. Yeah, also you can use environment variables, and for building image for each environment. Yeah, but we use secret manager for it. Yeah, and also we store some configuration inside secret manager because it's more useful. You don't need redeploy application, yeah, and you can change it in each time, yeah, without any problem. Spend maybe 1 second.
Okay, and the last question is from Adil.
Thank you. So in one of your slides, I saw that while creating a custom element, you were appending it to the DOM using the renderer. And alternatively, as far as I understand, we can just go ahead and use document itself to create an element and append it to the DOM. So what is the difference between these approaches, using the renderer and the document?
Yeah, if we use renderer, usually we affect some angular change detection. And for us, it's important because we have some events which should affect our application inside our layout. And after changing some clicking, some events inside layout, yeah, we need do some action inside our application. Yeah, and it looks like our layout, it's some wrapper. Yeah, it's separate application, and inside we have another application. Yeah, and yeah, but yeah, you can use DOM and create element, yeah, from a document. Okay, so thank you guys for your attention.
Thank you. Thank you, Ivan. So let's invite our last speaker, Viktor. From AWS team. As they say, last but not least.
1, 2, 3, yeah, it works at least. And I need my presentation, just 1 second.
Guys, you may sit a bit closer since we have a lot of empty seats here. A lot of. I swear. Yeah.
This one, CI/CD.
Uh, Hello everyone, my name is Viktor and I'm from AWS. I will be moving through the scene because I'm very lucky to do it, like to interact with you and so on. Thank you very much. I remember that I have to look at this camera, but anyway. So I'm going to speak with you about CI/CD. I'm not going to speak with you about CI/CD, how we can implement it based on AWS services or based on some other services. I'm going to speak about some principles. What is CI/CD, how to implement, I mean, like what kind of approaches, patterns have you do it on your project to achieve the best solution, I mean, like best CI/CD. So, and during my presentation, we are going to speak with you about different topics like what is release lifecycle, what is CI/CD journey, what's the metrics, how we can measure our CI/CD, because it's very important to understand what the current happened with your application, I mean with your process, for example. If you implement, I don't know, CI/CD or some automation, is it helps for your project or not, or maybe you have to do something else. Also, we'll review my blueprint, something like that. It's like based on my experience, because who knows me that I have been working for EPAM more than 10 years almost, and during this career in EPAM, mostly all of the projects where I engaged, I create and build some CI/CD pipelines. PTTP, one of the projects, and a lot of another projects where I try to implement, some best practices. Of course, best practices, it's not a real world. Yeah, we should understand, like best practices is like what we recommend, and depends on your situation, depends on your business needs, you can implement. And during this whole 10 years, I collected, like different some small pieces, advices, tips and tricks, and create just like summarizing this presentation. So first of all, what is release lifecycle? Release lifecycle is like when we create an application. In general, there are only 4 main steps. Some of them you can say only 3, just like source, build, and production. But in our case, of course, we have to do some tests, and there are 4 main steps. And depends on this, like these 4 steps, we implement different step of CI/CD process. But when I speak with different people and ask them, what is CI/CD for you, where you have to start your continuous integration? Some of them like say, it's CI/CD for me, it's my Jenkins, or it's my GitLab CI, or it's my build server, where I build something, run some test, automation, all of the stuff. But on reality, it's not true, because integration is when we're working with our Git source. Because if you engage in development and collaboration with multiple developers, I know 5, 10, 20 people, and you finish together at the same time different features, for example, or fixing bugs. The first steps, when you integrate it, it's your source code. It means like when you finish with Git merge, it's your first step of integration. For that reason, I would say that continuous integration started from step 0, like before you do anything, before you create any Jenkins or some other pipelines. The first one, you have to understand what the branching strategy will be better for your situation, will be better for your use cases. And when I speak about branching strategies, just like in my mind, I have only 3. Some of them, like you can say maybe 5, maybe something, another number, but anyway, 3 current main branching strategy. The first one is Git flow, and I believe all of you is very familiar because it's one of the oldest approach. If you know this diagram, Vincent recently created this one more than 10 years ago. And what's the interesting fact? That Vincent, just on the previous year, said, guys, I created this branching strategy more than 10 years ago to create box application. When I say box application, I mean for example, I deliver it to compact disk, if you remember, what is it, and deliver it to my customer, put to my laptop or to my computer and install it. And it means I have release lifecycle very long, for example, every 2 times in a year, every 6 months, or 1 time in a year, or I create, I don't know, for example, a game like God of War, which recently was released to PlayStation, yeah? So it means I create one product for a long period of time and deliver it. One of the main, not benefits, one of the drawbacks of Git flow is we create a lot of branches. Some of you say how I can create a feature which is not going to be delivering this sprint, for example, we are going to do it in the next one, feature toggle. My answer, feature toggle. And I also will speak about a little bit about feature toggles, what is it and how to work with feature toggle. But anyway, so Git flow, from my opinion, it's a little bit outdated. And if you can change your opinion, for example, to GitHub flow, because GitHub flow brought for us code review, and code review is very important practice. When you finish your work, you are going to merge this and collaborate with your colleagues and share with senior, for example, or another colleague. And you both will learn something new, for example, from your code, just like, for example, to review how to write or just like provide some feedbacks. And GitHub flow can help us to collaborate, can help us to avoid the situation that we create a lot of stuff and I really hate the situation that a lot of developers create huge results of work and we are going to merge it, and it's this pain every time when we need to create a merge conflict and so on. GitHub Flow is more popular, and if you work with GitHub is also recommended to use it and just like implement it. One of the biggest benefits here when we create a feature, as soon as we finish with our feature, we close it and forget about this feature branch. Because in Git Flow, we create a feature, and this branch can live for a long time. Also, we create a release branch, we create, for example, hotfix branch, and so on, so on. In GitHub, we have the main central line, like main, master, doesn't matter how to call it, and some separate feature branch. As soon as we finish, we squash, for example, this branch, we merge and delete it. Another branching strategy is Git trunk-based development. Yeah, I prepare for this projector. So, trunk-based development. What's the difference between trunk-based development and GitHub Flow? We create a feature branch, but this feature branch is so short. Every day we have to merge back to our master. And the main idea of trunk-based development is that every time, at any moment, trunk it should be predefined, should be stable to deliver to production, for example, or to deliver to some projects. So, trunk-based development, we create very, very short life branches for one day, and if this feature branch should live a little bit longer, at least we have to, to get the updated version from our master or from our trunk and make sure that we are going to merge it tomorrow. We prepare for that. Like, we will not have so much differential between my current branching strategy, my current branch, and what we have in the trunk. And also, again, it's the same question, just like how to work with situations that we are working on a lot of features, and if I need to deliver this feature today, for example, or like in 2 weeks, how I can merge it still to the trunk and don't broke everything. So feature toggle, one of the main idea of this one, and we can work with our application. For example, what is feature toggle? Just like to explain a little bit. I'm working on some functionality and create some configuration or some flag and turn off this feature flag. It means like I turn off this functionality and I can continue to working on that, and nobody cares that I broken something inside my feature. And you know what's the interesting fact? And at the biggest tech company like AWS, Google, I don't know, but I just like think and heard about that. They don't create rollback if they see some issue on production. They turn off some functionality using the feature toggle. Just like disable this feature because we see some issue, some problem with our production, for example, in the current moment, and the prefer way just like don't roll back, because rollback anyway will take some time, and we will speak about what is deployment strategy and like what's the best practices. But mostly when we see some issue in the production, we don't run some rollback to the previous. We turn off this functionality. So, as I said, like we are going to draw blueprint for CI/CD, and the first step for CI/CD, just like for continuous integration, first of all, is like how we store our code. What's the branching strategy? What's the source code? I hope all of you use only Git. Maybe some of you use SVN, but I hope that you use Git. So first of all, we will see a lot of quality gates on my blueprint, and this quality gates, it means like as soon as I see some issue, I have to stop my continuous integration, continuous delivery pipeline. In this case, when I'm working with source code, I am going to merge, and some of my colleagues review it. Like code review run, and we understand like this code is not not very good and we have to change it a little bit, we stop. I mean, like our quality gate, just like say, you will not pass. I hope you remember from which film this phrase. So you will not pass, and we have to back to the previous state, fix it, and move on. So it was related to the source. What about build and test situation? I mean, like what's in the phases test and build? And continuous integrations here, like what's mostly all of us understand what is continuous integration. Of course, it's some automation process. Mostly it's some tool. It can be TeamCity, it can be GitLab, it can be AWS services like code commit, code pipeline, so on, so on. Doesn't matter, but anyway, we run for every event, I mean like for every pull request, for every commit, some automation process. Of course, we run some couple of tests. And this is very important to understand what kind of test. It will be only unit tests mostly. Also, we understand what's really happened with our code base, run some static code analysis, tools which help us to understand, for example, to figure out that I have not committed some secret data to my source code. And what is the most important is feedback loop. Continuous integration, and the main idea of continuous integration is feedback loop. Because when we focus on our task, as we are working as developer, when we finish and when we push it to Git, for example, and continuous integration process run, we can lose the focus of our feature. I mean, like we go to the coffee, take a coffee and drink, for example, water. And if it takes more than 50 minutes, we will lose our focus, we will switch to another task. And you can imagine like you change your environment, you change your workstation, and you have to back to the previous state. You have to back to the previous focus what's happened with this feature, what's happened with this code base, understand, and it also will take some time. And the main idea of continuous integration to short this period, like to make sure that it will not take them 15 minutes, because during these 15 minutes you can stay on the focus, you can understand what's really happened with your code. So what exactly will added as a step of continuous integration on this area? First of all, as we can see, we add some build server. Of course, we see some dashboard. Dashboard is very important because on the dashboard we understand what's the status of continuous integration. And also we add some couple steps. The first one is code analysis. Code analysis, it can be anything, but it can be SonarQube, like very complex solution where you review your code, like to understand some code smells, some bugs, and so on. Or it can be very simple and easy, like some linters for your code, like for Python, for JavaScript, and so on. You can start from some simple and move on to some complex solution, just like to figure out that you have not committed some secret data to your code. Another one is build. Build is also very important. So from the build perspective, we create an artifact. And this artifact you have to deliver from one environment to another environment. So the output of continuous integration, it's artifacts. It's maybe Docker file, maybe your jar file if you're working with Java, or maybe some binary files, for example, with Go, if you're working, and so on. And this build, these artifacts, you store some artifact array and deliver it from one environment to another environment without any changes, without to create new artifacts for new environment. Unit test. I believe all of you understand like what is unit test, but to make sure that we are on the same page, understands what is unit test. Unit test, it's when I test functionality of my code. I don't integrate with something. For example, I don't store anything on my file system. I don't integrate it with, I don't connect it, for example, to that database. It's not unit test. Unit test, if I have some function, for example, a plus b, and in input I provide 2 and 3, for example, result should be 5. That's it. It's integration. It's unit test. Integration test when we integrate it with something, with third party, with file system, check the results, maybe, I don't know, communicate between another microservices and so on. And put all of these results to our artifacts. Because from the build perspective, we create artifacts and store it in our artifact services. I don't know, maybe it's Nexus, maybe another solution. So, and also when we finish with this build, I mean like with continuous integration phase, so we finish with continuous integration phase, we mark our artifact with some version. And my preference is use semantic version. It's very popular, and also I believe all of you knows, but also the same, I want to make sure that we are the same page. The first number of semantic versions, like measure version, it's if I change this measure version, I can make some break changes, like for example, Python 2, Python 3. I can use Python code on from version 2 and run on Python version 3. The second number, it's minor. It means like I create some changes, for example, but bring some functionality, but at the same time, it will still work on the future. And the last one, it's a patch. It can be, you know, some fix bugs and so on. And I also highly recommend in batch version implement your sum of Git. I mean, like when you see the results of you commit it, yeah, and you also put it on the batch version Git commit. It will help you to trace what's really happened. I mean, like I have an issue on my production. What's the version installed on my production? Version 1, 2, 3, for example, and Git sum. And then I said, okay, I can check out on this code base. And I can very quickly to analyze and understand, okay, there is some bugs, for example, and I can very quickly to see and investigate. So, looks like we currently finished with continuous integration and ready to move to continuous delivery. And on continuous delivery, the main idea is like, based on my results from continuous integration, I start to deliver it to somewhere, to some environment, to some places where everyone can see how it works. For example, for internal needs, I don't know, only for developers, maybe only for another team like with QA engineers, maybe for, I don't know, project manager, maybe for something else, maybe for another third team who also work and integrate with our environment. And we remember that continuous delivery, it's a fully automated process, but for production, we have some switch where we finish, for example, with our old test. We understand that this artifact is ready to be delivered to production. And I don't know, maybe some release manager, maybe QA team or tech lead or solution architect say, let's deliver this version of our artifacts to production. So the final step for continuous delivery to the production, it's manual step. What exactly we can see in our pipeline, I mean like in our blueprint? First of all, as we can see, we add infrastructure provisioning. And it's very important to understand like for continuous delivery, when you start continuous delivery, you have to configure your environment. I said infrastructure provisioning. It can be anything like infrastructure is called CDK, for example, yeah, where you describe your AWS environment or your Kubernetes environment, how it should be configured and so on. But at the same time, if you're working only with virtual machines, maybe it will be included your Ansible playbooks to configure these virtual machines. But anyway, the main idea is for continuous delivery, you also include infrastructure provisioning with configuration management, like Ansible, Puppet previously, currently it's not very popular, but anyway. So you prepare the fully work environment, and it should be fully automated as much as possible. If you add some manual steps, you bring some human mistake. So we create our environment and deliver our artifacts on our first integration environment. I call it like it's a dev environment. You may call your dev environment in your local machines, like in your laptop, but in my preference to call dev environment, it's where I can integrate with another developers, where we can integrate and work with another teammates. And again, we run additional tests. There is, you can see integration tests. It's integration tests, I believe you understand, like I can integrate with another microservices or with third-party services, or maybe with some databases, I don't know, like run some scenario and see what's really happened. And also run some acceptance tests to make sure that it works correctly and it's fit to my requirements, what was in the tickets and how it currently realizes on the results and how it works on my first environment. But continuous delivery is not finished on this step. As I said, on continuous integration, we create our artifacts, our Docker file, for example, and delivery from one environment to another environment. And here we go, for continuous delivery, we create additional environments, And as soon as we see, for example, all of our tests pass on dev environment, we're ready to deliver it to another environment, for example, QA environment, or maybe staging. On the next one is UAT, user acceptance test, or pre-prod, or maybe some another environment. And for every environment, we can run another couple set of tests. I don't know, for example, in UAT, it's like super close to my production. I can run performance tests to make sure that I don't bring some performance issue, yeah, and compare with the previous version. Or I can run additional security tests. We remember in our quality, when we run code analysis, we also run some static code analysis with security checks, but here we can run some additional security tests on the whole in our environments. So from every environment to new environment, we add another type of test. And again, it will depends absolutely on your business needs, on your application, the complexity, and so on and so on. On some project, I didn't implement performance tests. On another project where we very, very strict for performance level, for every commit we run performance tests to make sure that we don't bring some performance problem and so on. Again, depends. It's blueprint, but in your organization it can be very, it can not include the whole steps, but at least you will see, the main idea. So, looks like we almost finished. With continuous delivery and ready to move to continuous deployment. For continuous deployment, it's a fully automated process. You can deliver it till to production without any additional manual steps. And I remember when I was on the project, we realized some social media for a lot of customers. It was like multi-tenant application, and every customer wanted a separate design. We implemented continuous delivery for continuous deployment for changes of designs. I want to change the color of this button. Customer don't want to wait for finish of our sprints every 2 weeks, and we implemented, we got some requests from customer, developer implemented, push it to the Git, and we understand, it's related to the static, some design level, yeah, and we deliver it directly to the production without affect another one. But at the same time, when we deliver it to the production, we have not to affect in distribution. We have to deliver it without effect of our end users. So when I deploy something to production, my customer should not see, for example, maintenance period is going to be, or my application currently doesn't work. It's not very good situation, yeah. And because first of all, we can lose the trust to our audience, and also our customer will not back to our application. So continuous deployment brings for us such approach like zero downtime deployments, and in general some deployments strategy which help us to deliver this our new changes to production without affects users, or maybe with some additional benefits. Let's review what kind of deployment strategy currently exists nowadays and what I see from project to project. If you look at for example, this diagram I got from deployment strategy for Kubernetes, but in general it will be acceptable for implemented for any another environment. I understand this is like a little bit busy slide, and it can be very difficult to understand. For that reason, I prepare and I want to explain all of these deployment strategies and what the benefits and maybe some pros and cons for all of them. The first one is recreate or with maintenance period. I don't know how it's in Uzbekistan, but in Belarus, for example, I got sometimes a message from my bank, like SMS, that we are going to make some maintenance period during the night. It means they're going to stop the whole application, and my card will not work during this maintenance period. And they promise that tomorrow morning it will be works, everything fine. So it means we fully stop our application and apply a new version, and then back to online. It's one way. Another way, when we implement immutable infrastructure, it's like a pattern. When we don't create new, we don't update on the current version, we fully delete the current environment and recreate it from scratch with new version. So it means I stop, fully delete, or stop my current application, my current environment, recreate or just update, and then back to online. Downtime deployment 100%. I have to notice about that my customers, like it is going to be some maintenance periods, it took 4 hours, 1 hour, 30 minutes, doesn't matter. So the next one is rolling update. When it's the first deployment strategy with zero downtime deployment, because I have some couple instances. For example, in this case, it's 3 instances. It can be 5 instances, for example. And I create a new version of my application. For example, I delete one of the instances from old application, from old version, and create a new version. And see how it's going on. I mean, like not from traffic perspective. I see that this application, new version, up and running, my service up and running, or my pod, if you're familiar with Kubernetes, has readiness checks and liveness checks, and everything works fine. Looks like my application is ready, and I'm ready to continue with my new version. I mean, like to deploy. So when I just like from delete one, the next one, the next one, the next one, the next one, and create absolutely the same with new version. And it's like provide for us zero downtime deployment. First of all, because we don't stop the whole application, we just like stop the couple of % of my application, create new version, and deploy new version on this one, and put the traffic to the new version. There is also exist 2 main approaches. The first one, when we delete it and then create new one. It's very suitable when you are not affected where your high load, I mean like with your traffic. Another way, when you still have your 5 instances, for example, and you create new version, you add to the current capacity of your environment, new version, I know, like additional new instance. And if you see like everything works fine, we can delete one of the instances, some couple % of the current environment, and then continue. So at any time, you will have at least 5 working instances, and if new version is like broken and something happened, we just like stop it and delete it. The next one, it's blue-green deployment. Blue-green, from the naming you understand here, you have blue and green environment. It's one of the expensive deployment strategy. And why? Because you should create 2 environments absolutely identical with the same amount of resources. I don't know, if you have on production 10 instances, in blue environment, for example, 10 instances. In the green also you need to have 10 instances. Because as soon as you finish, as soon as you're ready to switch to new version, you use some network device, for example, load balancer, or maybe some another network devices, and you just switch your traffic from old version, for example, from blue to green, and see what's happened with new environment, like how your traffic process, how your clients worked. And if something happened wrong, I don't know, like we see a lot of 500 errors, we can very quickly switch back to the previous version and switch our traffic to the previous version. So, as I said, again, it's zero downtime deployment, but it's very expensive. But again, it's bring for us some additional benefits, like super quick rolling back from old environment to new environment. And also we can test a new version of our application. I mean, like our users, not users, our QA engineers, we can internally test the new version, for example, the green version, how it works. Of course, we can have some issue with databases, but it's again need to discuss and what's the pros and cons, how we can work with databases. But anyway, the next one, it's a canary. And you know, like I very like the story why it's canary. I hope all of you know, like canary, it's a small bird. And previously, many years ago, like maybe 100 years ago, or maybe more than 100 years ago, miners who works underground, and not the current miners who try to bring some bitcoins and so on. No, the previous miners who worked underground, they use a canary as a bird to check the quality of air in the underground. Like they use this bird, put in the underground, they check the quality, what really happened, can we breathe there, and if this bird is alive, it means like I also can go to this underground, and as a human I will alive if this bird is alive. There is absolutely the same approach. I move my traffic, like switch my real traffic from my production, 5%, for example, and send my real users. and see what's really happened. My canary is alive, my bird is alive, my traffic is alive, I don't see any 500 errors, my logs is clean, my monitorings don't create a lot of alarms, for all, so on and so on, and I can switch the whole another traffic to this new environment. Or I saw the implementation when we create canary 5%, for example, in the first batch, the second one 20%, then 50%, and then the whole percentage of traffic. Again, depends on your implementation, but in general, canary, it's like when we create new environment and send, for example, 5% of traffic. And if it works fine, our real traffic works fine, we can switch the whole another 95%. It's also zero downtime deployment. It's also very quickly to switch it back to the previous version, because if we see some issues in new environments with this new version, we can just like delete this 5% and don't move into the next, moving the whole traffic to the new version. The last deployment strategy, it's A/B testing. A/B testing is very almost the same as canary deployment, but with one small important point. A/B testing is when I create new version, maybe it will be very familiar if you're working with some UI, yeah, and you're going to test some new version of your UI. I don't know, for example, you want to full redesign your application, and you don't want to deliver new version of this design for the whole audience. Yeah, you want to test on the couple users, and these users will be target users. I mean, very good example, e-commerce. Yeah, you're going to change the process workflow of how our end users buy the product, and you don't want to deliver this workflow for the whole users. Yeah, you want to deliver only for users who spend $100, for example, per month, and test on this audience. So you deliver for the small amount of target users. Very important, target users. So you select these target users, deliver a new version for these target users, and see, just like based on the business metrics, not the technical metrics. I mean, like not based on the logs or alerts managed or monitoring and so on. You test your business metrics, how is going on with our end users, how much money users spends. Or for example, in gaming, it's also very popular deployment strategy. When they create some new logic in game, for example, delivering some couple of users and check how much time the user spends with new version of the game. If it's less, roll back on the previous version and see why this happened. So just to summarize, I back to this very busy slide and just like want to show you again how many deployment strategy we currently have. So the first one, it's recreate. As I said, it's with downtime deployment, and it's also pretty just like doesn't need additional resources, so it's very cheap. But if you need to roll back, you have to stop the whole environment. Again, move this back to the previous, like recreating the whole environment or update this version of the previous one. The next one, it's rolling updates. It's also pretty easy to implement. I mean, like you can find a lot of different tools which help you to do it. I mean, like in AWS and ISG, for example, after scaling group, you can do it very quickly. Or in Kubernetes, out of the box deployments provide for you this one. I mean, like deployment, rolling update. You just like say, I want to update to the new version, and we'll start this process like every 25% update to the new version. The next one, it's a blue-green, and as I said, it's one of the most expensive solution from cloud perspective cost or from resource perspective cost, because we have to create the second environment absolutely the same with the same amount of resources, so you have to pay for these resources. So be careful with that and just like make sure that blue-green is like very suitable for you, I mean like from money perspective. But at the same time, it's one of the simplest and the fastest way to roll back, because it needs to just like to switch traffic to the previous version, to blue or to the green version. The next one is a canary, and as I said, it's we can test real traffic. I mean like real traffic from our users and canary on the canary deployment. It's absolutely the same with A/B testing, but what's the difference? As I mentioned, for A/B, you can test some real target users, like target users, which we want to test to make sure that will not affect our business metrics, for example, how much money our user spends, how much time user spends with our application, so on and so on. So it's like what I currently see from the deployment strategy on the, like on the market, but it was everything was related to continuous integration, continuous delivery, deployment. It's a process, yeah, and we can measure our process. I mean, like we can understand our continuous CI/CD process is good or not, or we can do it a little bit better. And if you're familiar with DORA, it's DevOps and Research Assessment, they provide 4 very important metrics. What they do is like they run a survey every year and across the worldwide, ask a lot of developers, software teams, to provide some metrics, like from their perspective. What's the metrics? The first one is deployment frequency. Yeah, and if you don't have your deployment frequency, I mean, like if you don't have your CI/CD, deployment frequency will be very small. I mean, like maybe every week you deploy, or every month, or maybe one time in a year, depends. The second metric is lead time. Lead time, it means like how much time we needed to deliver it to production. As soon as I finish my work, as soon as I finish and merge my result of my work to the Git, how much time will need to move it to the production, yeah? The next one is how I can fast rolling back if something happens during the failures, and also time to restore and how failure rate, yeah, how often this happened with production. So based on these 4 metrics, DORA, DevOps and Research Assessment company, just like they say, like we have 3 different type of software development teams. The first one, it's like, let's say, like I don't want to say it, but anyway, it's the losers who not very productive. Yes, they have a lot of points for improvements. The second one, it's the middle, but also they say you can be light, like you superhero who can deliver on demand in case if you need it, yeah. Your failure rate is very, very small, around 0% or 50%, and your lead time less than 1 hour. So it means like if you have some new functionality, if you have some new ideas, you can very quickly deliver it to the production. So based on these metrics, we can measure our continuous CI/CD process. But as I said on the start of my presentation, during the last 10 years, I was on the different projects and I collected my own CI/CD metrics. What's this the metrics? It's very custom. It's not like, you know, industry standard. It's my own, where in some cases I say, let's measure this one, or let's measure this one. So what's the metrics we have? The first one, it's in which I believe one of the most important, it's time to feedback. Because as I said, for continuous integration and for continuous delivery, it's very important to be on time. I mean, like how much time will take to provide for you some feedback. Because if it takes more than 50 minutes, here I put 30 minutes, but anyway, 50 minutes from my perspective is the best way. If you can provide the feedback during the 50 minutes, developer will not lose the focus, like what I'm currently working on, got some feedback, for example, from unit tests, maybe from your integration test, maybe from static code analysis, maybe from something else, from our CI/CD pipelines, and very can quickly check and fix this issue. We remember that for continuous integration, continuous delivery, we have some quality gates, and quality gates can help us to stop this process, provide feedback for end user, I mean like for our developers. So it means like we will not waste the time of developers, and also will not waste the resources, I mean like from money perspective, from CPU, cloud resources, and so on. Another one, it's like pull request count, but nowadays I would prefer to say pull request cost. And if you're working with AWS, highly recommend open source solution. It's infra-cost solution, where you can, if you're working with Terraform and AWS, for every pull request, you can see how much money it will take for this pull request. For example, you would change the size of your RDS instance. It's our managed service for MySQL or Postgres relation databases. Or you change the size of your EC2 instance or create new instance group or something like that. You can see how much money it will be cost for your pull request. So if we summarize, how continuous integration, continuous delivery blueprints looks like the whole way. I mean, like when we finish from the start and to the production. This picture, and very important also to understand that I absolutely forgot to mention that continuous delivery also should start from implementing environment, but also you have to monitor your environment. And as soon as you create your first environment, you have to understand what's happened with your environment. I mean, like you need to create some monitoring solution, some alert solution, alarm solution, to be sure that like you will be the first who figure out that we have some issue on our, for example, dev environment. Why, you ask me why I have to be care about the dev? It's like a dev environment, only a couple people work on dev environment. But imagine a situation that you're working on some team, yeah, and you have developers, you have business analytics, you have quality engineers, you have DevOps engineers, and so on, and all of them integrate on dev environments. And if you're broken dev environments, it means like you affect another people, and for these people it's like work stoppage. And again, we waste time for these people, so be careful and be care about your environments and create monitoring solution. And also, if you see some issue on dev environment, you create alarm, but alarm it's only the first step for your monitoring solution. You have to create some instruction what I have to do with this alarm, yeah, because if I don't know how to fix this alarm, if I don't know how to fix my production, yeah, it doesn't matter, like I have this alarm and I don't have, because I will need to troubleshoot and so on, so on. For every alarm, you also should create some instruction how to fix it and store in your documentation. It's a very big topic about documentation, but anyway, my recommendations start with monitoring on your first environment. And let's very quickly, again, just like go through the whole pipeline. The first one, as I said, we are starting with code. We are starting how we store our code with our version, and the first step is code review. The next one is our continuous integration. Code analysis, like SonarQube, or some another static code analysis, like linter. We run our build, unit test, we got our artifacts, we create the first environment from infrastructure as code approach, like CDK, for example. Or if you're working only with virtual machines, I don't know, maybe you run some Ansible playbooks. So anyway, we got the first environment and delivery our artifacts on the first environment. Run a couple of tests like acceptance test, integration test, and create new environment like QA, run some additional synthetics test. If everything works fine, our quality gate still is green, we create a new environment, UAT, runs performance test. Again, if our quality gain green, we are ready to move to the production. In continuous delivery, we remember we have to push the button and say, please deploy these artifacts to production. And finally, we are on production and we finish with our continuous CI/CD pipeline. I hope this session was useful, and we are working on for AWS, and in AWS we have the culture to get some feedback from your side. I mean, like, from my presentation, I also will be very pleasure if you scan this QR code and leave your feedback, so like, do you like this session or not? And also, if you understand and can speak in Russian, just like only understand, you can subscribe to my couple channels. It's AWS на русском and my personal YouTube channel, DevOps Kitchen Talks, where I speak about DevOps, not only about AWS in general, about DevOps, and not only about DevOps IT, industry, and so on. Happy to answer to your questions. Okay.
Yeah, I'm running.
Faster, go, go.
Hello, thank you for your great speech. It was really beneficial for us to get to know the modern CI and CD blueprints. Well, as I could understand your speech, well, the code should go to the preferred test before it published to the users. Well, what it would be like if we made a really small change in code and they goes to this process and it takes time. So I guess it's not good, right? Well, Because
yeah,
with small
absolutely.
change, you have to wait for that.
Yeah, absolutely. Because like when you make some small changes,
Even small changes. Yeah.
even small changes, doesn't matter. Because I was in a situation when a developer came to me and say, Victor, I changed only one line. Let's deliver it just like without all of these tests. Just like I will not break anything. And you know what? Everything was broken. Cascading broken, and nobody understood like what's really happened. Why, if I change only one small of line of the code or tiny changes, as you said, I broke everything. So my thoughts about that: you have never delivered to production without run test, because if you want to deliver to production like to production, so it means like you can break everything, or you just like apply philosophy, I test only on production. It's up to you, of course, but in normal situation, we have to go through the whole process. And what I said, like for continuous integration and delivery, it's very, very important to measure this time. How long it will take to run all of these steps.
All the process,
Yes, because like if it takes, I don't know, a couple of hours, it's not also a very good situation. Maybe you need to implement some cache solution, because I remember one of the projects where we working with C++ solution. Only CI, only build process and the runs of tests took more than 2 hours. This looks like too much, yeah, because 2 hours my commit and my colleagues commit, another only 4 commits during the day. That's it. It's not possible. Yeah, it will not work. So we found some cache solution for C++, and we not built the whole project. We built only, so we have the base, yeah, and built only the differentiations. So it took more than, I don't know, 2 or 3 times less of the time, and we can deliver it faster. So it means like during the day, we can check how many pull requests we proceed, how many this commits on the Git, we can proceed. It means like, I don't know, I have 10 developers. How many commits I can check during the day? For that reason, I said like you have to measure your continuous integration. Measure these metrics, it's very important.
Okay, who's next?
I don't remember, sorry. Let's, from the first line.
Yeah, hello Victor, thanks for the great presentation. So my question is...
You have a list of questions, looks like if you take your phone. Okay, I see, okay,
yeah,
got it, okay.
So based on your experience, what are the best practices for handling user authentication after load balancing of application?
Sorry, can you please repeat what you mean, like authentication users and load balancer?
So let's say we have kind of distributed, and we have the load balancer, right? And one request can go to one server and another request can go to a different server. So we can lose user authentication. So in this case, what do you think, what can we do?
Honestly, I don't know how it's related to continuous integration, continuous delivery, but I'm prefer to say maybe some service mesh if you're working with your with Kubernetes. But in another way, I believe we have to go to and troubleshoot why you lose this authentication. So it looks like your ILB, your load balancer, delete some, change your package, and so on.
No,
so let's say you have a roll and upgrade, Yeah. I know. For that reason, if you look at the very careful on this slide, you will see that for rolling update and for blue-green, I have another characteristics like negative impact on user. So it means like, for example, for blue-green, I can lose my sessions, like I was on the previous environment, and currently I switch to another one. And for rolling update is one of the way where also I can affect my users. Yeah, but don't implement some sticky sessions, so your application should be fully stateless when you not care about where you send your data. I mean, like, my user is going to buy some stuff, and I store this stuff, I don't know, maybe in DynamoDB or maybe some another stateful services, and like when I switch to another one, I don't lose this session. Session for me, it's only the user. And the user, it's your cookie located in your, I don't know, or your GVT token. Mostly it will be on your client side.
Sure. So you have to cache
Yes. Yeah.
Thank
Okay, who's next?
I don't know. a lot of
Let's go on that side.
Okay. Yeah. Please.
Wait a minute.
Hello, thank you for presentation, and especially for metrics, it could be really useful, especially for me. So my question is about the. Oh, sorry, I so wanted to ask the question that I forgot what it was.
The last question was related to load balancer, and during the deployment, I can lose my authentication for users if right understood the question.
No, I mean I forgot my own question.
Your own question. Sorry.
Yes.
I don't know. I cannot read your mind. Sorry. I'm growing on this one. During my DevOps career, I tried to read, like thoughts from my customers. Sometimes sometimes I was able to do it, but it's very difficult.
You can try.
Metrics,
I think it was about
you like metrics?
Metrics, maybe. I don't know. Sorry.
Okay.
I know who will win the T-shirt. The best question.
Yeah, as I'm here, let's.
Hi. First of all, great presentation. I really love how you work with this words place specific for this. Yeah, that was cool. May I ask you to return back to the blueprint?
Yeah, of course.
I love the stages about testing. Yeah, we all love this testing, and all this stuff, it's about a component layer. Yeah, service layer maybe, but we also know what the huge business system have one more layer of a test called end-to-end system test, which can be very time-consuming. We should go through all this business logic, and for a huge business system, it can take hours and days in some specific case. Where in this blueprint you will locate them?
I believe it's located here somewhere. I mean, so you can do it. For example, in your UAT or your QA environment, run the whole of your end-to-end test if you write this to the equation. And I know some customer who need to run, for example, performance test. It's ClickHouse. It's not like super secret. ClickHouse, if you're familiar, what is it? It's the databases and analysis. They run performance tests, and this performance test took around 8 hours. So they create a new environment for every commit and run this performance test, because for them, ClickHouse is very, very intensive application. They need super high quality of performance. So they run new environment for every commit. And when I say it's a blueprint, so you can create a lot of environments. It can be, for example, dev or feature environment, something like that. And you create for all of your features additional environments. For example, through the different build system like TeamCity or GitLab or something else, and run all of your tests which you needed. Of course, you will need to pay for that. But if business say, I want to run the whole of my test, and it doesn't matter how much it will cost, please go ahead.
Okay, in this case, one small additional question.
Okay.
What do you think about the scheduling? Not running on each commit and pull request, and maybe have a scheduler for daily basics run. Would it violate the continuous operation ideology in this case?
In my case, where we run schedule tests, it's like fully covered test, UI, unit, integration, performance during the night, and got the results at the start of the day. So quality engineer, she started her days, check the results of this test and moving on. So in the whole of this process, sometimes you don't need to include the whole test. For example, you're going to deliver it to the production, but for dev environment, you need to run the whole test. You need to run as soon as possible the results, because it's only included unit test, our build and code analysis. You got your dev environment. But how long you need to be on the production? Yes, it can take some time. But the question related to some small, tiny changes, you run at least, for example, minimum amount, scope of tests. It can be, some different triggers like configuration. Please run the full test. run the half of test or run some small minimum of test to check your basic functionality. Just like, for example, I can log into the application, my backend works fine, my front end can communicate with backend, something like that. That's it, and move into the production. So long story short, answer your question, yes, you can have different type of tests and run an on schedule, like during the night, just like to avoid situation you, for example, your dev environment currently is busy because we run a lot of tests, and nobody can work with this dev environment, cannot deliver a new version. But for production, and if you need to very quickly, you can run not the whole test, but run some small amount, just like to check the quality, make sure that your application will be run at the minimum configuration, at least minimum test configuration. Yes, you can do it. So, for example, in the unit test, when we are working, I work for one of the project, we have so many unit tests, yeah, and for these cases, as I said, like you have to, at least you have to, yeah, but for production, when we need to deliver to the production, we run some small amount. And also, we create unit tests, which is not unit test and integration test, which was not dependent of each other, so we can run it independently in parallel mode, and also improve this process. I mean, like how much time we spend for this one. The same situation with UI, also just like try to find the situation when you can create it independently from another test and run in multiple threads and multiple, I don't know, build agents, something like that. Yes. I see at least two hands, three hands.
One more question?
I don't know how much time do we have.
Do we have time, Marina?
Maria, do we have time? We have time till 9 p.m. No. Okay,
we have one final question. So, Viktor, you should choose. Okay, I'm coming.
Anyway, I'm still here. We'll be here if you want to speak with me. We'll be happy to answer any of your questions. And yeah, you can ask English, Russian,
hello.
Belarusian.
Thank you for great presentation. It's awesome. My question is, are there any stable strategies exist in continuous delivery that help us to handle infrastructure changes? For example, database migrations that introduce some structural changes, like splitting columns, changing column types, and so on. It's not that easy to hide them behind feature toggles, I think. Yeah, thank you.
For that reason, as I said, like you have to implement your infrastructure as code, your configuration, your environment configuration, infrastructure, all of the stuff to continuous delivery. And if you're working, I mean like your feature required new services or new type of functionality in your environment, you also should include it in your continuous delivery. So it means like system engineers, like DevOps, and your developers, or your developers is ready to write CDK code, for example, it should be included as feature, just like definition of done of this feature. So it means like if you want to finish with this feature, you have to make a changes in your infrastructure as code, configuration management, depends, and your code. In your code, you can turn off your functionality. I still believe you can do it through the feature toggle. I still believe you can do it. But yeah, when we implement it in infrastructure, just like to deploy new, I don't know, RDS or new services, yeah, it will be much, like it will be very difficult. Maybe through the CDK can be, just like to check that, should I deliberately create the services on production, or I need to deliver these services only on dev? Because in Terraform, it's very difficult to implement conditions like if-else. In CDK, one of the biggest benefits from my perspective is the logic, when we can say, should I do something for these parameters, for this environment, or not? So I hope I answer your question. Again, thank you very much, and I will be very happy if you scan, sorry, not this one, happy scan QR code and leave your feedback. Yeah, and thank you very much for Learning Scope conference. Yoo-hoo!
Yo! Okay, so thank you, Viktor. Thank you, One more question?
The best question, this one, guy.
Yeah.
Sorry, you forget your question.
Okay. So we in the final part of our meetup. So it means that we need to sum up the results of meme contest, and actually we have winners, 3 winners. So Safar will connect notebook, Mac, and we'll see the results. Yeah, and by the way, the results for memes, the winners get the power banks from Rolling Scopes. So the third, nope, not third, okay. So just press the next button. Yep, you can do this. Yep. Okay, Zen Buddhist, awesome. Yeah, but we want to see what the, okay. One more task, Jack. Just one. Okay, yeah. I heard from my project manager every sprint at the Friday. Okay. So the next, hold on, Zen Buddhist, where are you? Okay, come to the stage, and we have for you the. And actually, you get from your resource manager. Okay, hold on. Okay, so Javahir Dev. Okay, so okay, going to RSConf. Yeah, nice. It's you. Okay, okay. You can get from Zaf. Okay. Okay. Okay, photo. Okay. And finally, the first place. Let's make some noise. Yeah, it's the first place. Fatoyev Azizbek. Come to us. Come on stage. And let's see. I like it. I like this one. This one the best, I guess. Okay. And yep. Yeah. Okay. Okay. Mentor and restore rolling scopes. Okay. But join EPAM and make some success. Okay, thank you. So we already we can move to the finally chapter of our meetup, and right now we can conduct the Kahoot. So I hope you're ready for that, and I hope you're waiting for that, because the winner of this contest will get electro scooter.
Yep.
So
Prepare your smartphones.
yeah, you need
Check
to.
the internet connection. It should be fast. It should be
Marina,
stable.
by the way, you can come to me and say more loudly using microphone.
I have my own.
Oh, okay, okay. I'm sorry.
Small but still working.
Okay.
So for
I have joke from our clients from America for that, but
no
I will
jokes,
skip it.
please.
Not for this meeting. Okay.
So are we ready?
We are waiting for
Okay.
We are waiting for a screen. Okay.
The magic.
Yeah, but unfortunately it doesn't transfer to the HDMI.
Yeah, awesome.
So
okay, you need to scan the QR code or go to kahoot.com and put this code. I don't know, 620 7763. This is the code.
Please follow to kahoot.it page.
Okay, nice.
And
where is our internet?
it works. Okay, I see that only 13.
Yeah, actually about rules, I should mention that first 5 topics will be something like we're loading, okay.
This is
internet issues. Okay.
Okay.
So new numbers.
Let's start again. Go to
365
6332.
332. Okay. There is about 50 people.
More than 50 people.
I encourage org team not to participate.
You should tell for speakers also about that.
And once again, org team, please do not participate. You will be disqualified.
Okay. So I think we should wait a little
Okay,
bit.
we have 91 participants.
Yeah, let's wait a few minutes just.
92 and 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Let's start.
I think that we can wait. Do we need to wait somebody?
Okay, I think we can start. Okay. So this is the just test question, just for you understanding what's going on and how to play this game. Okay, let's go to the first slide. Okay. Okay. Okay, somebody. Okay.
I have some questions to
About
those
Square.
7 people.
How Square look like? Okay. So I think everybody understand this type of tests. Okay. Let's go to the next. Multi-select. Okay, orange is. I like it. Okay, nice. So incorrect answer from somebody perspective is correct. Okay. 2 equals 3. I think it's true. You should choose true. Okay, yeah, 7 people is already to. Yes, awesome, awesome. maybe. Okay, let's go next. Oh, that's hard one.
Is it still testing? Okay.
Yeah, different types. I think we should start from 3, then 2, then 1. No, then 4 and 1. What do you think, Marina? Okay. 38 people said that's okay, nice. Okay, so we start serious questions. So how to manage AWS cloud infrastructure with TypeScript?
Question from Andrei.
Questions from Andrei.
And for this question, you will get points. So you should be right, and you should be the quickest one.
And also don't listen my hands from me, because I don't think I will help you. What languages are supported by AWS SDK? TypeScript, JavaScript, TypeScript, Ruby, Java, TypeScript, Python. Okay, I don't need to repeat the answers? Okay, okay. Okay, 50 people choose correct answer. Let's go to the next. How to spell the first Vade? Okay. What SDK means? I like this picture. CDK? Okay. I'm not a developer anymore, so whatever. Okay, Cloud Development Kit. Okay.
So we have a new leader, Golubev.
Okay. What AWS services are used by AWS CDK? Am I correct, Zafar? CDK for provisioning. Okay. Cloud formation. Okay. And who's the leader? New leader, Yusuf. Okay. Let's go next. Actually, Marini, I think your turn to read down questions. No, you don't think it's a good idea? Okay. Oh, leader is TypeScript.
TS.
TypeScript. I like it.
So we are moving to the bunch of questions from Mike related to his topic. Order these based on the level of abstraction and focus on business logic. List is first.
Did you get it? Serious music for this question is more hardest.
Something mysterious, these.
Yep. Okay. 25 seconds left. Oh. It's not a mysterious, it's just like a thriller or something like that.
5 seconds left.
Okay, and we have comics.
As a leader for now.
Am I correctly spelled comics?
Which of these AWS tools are data store tools?
Five seconds.
Time is up.
Shoha. Okay. So, by the way, did you get it? In each questions we have a new leaders. Cool.
It means that the result is unpredictable.
Yep.
AWS Lambda functions are stateful. I think it's easy question.
You think it's question? Or not?
Easy.
And
Not
false.
so easy.
Not so easy. Okay. And again, comics. Okay. Multi-select.
Types of event sources for AWS Lambdas.
New
and
leader.
A new leader, Rustam.
We get it.
Types of Lambda invocation. And comics is leader once again. AWS Lambdas, where should you initialize clients and database connections? Guys, don't give up. You still have a chance to win.
Okay, I think we
Almost no changes.
saw the leader comics. And we transfer to next section, the
From Egor.
speech of Egor
Talk.
about Amplify, low-code system. You can become a senior software engineer in 3 months.
Mainly, whose work does AWS Amplify intend to simplify?
Marina, you said it without any, fire. I think mainly, whose work does AWS Amplify intend to simplify? Yeah? What do you think about it? Frontenders, yeah, for sure. We don't like to work a lot.
What type of development does AWS Amplify is?
I think DevOps, from my perspective. For sure, DevOps. Yeah, 4 people think so, yeah. Okay, new leader, Rustam.
AWS Amplify supports GraphQL.
Rustam still in the leader.
How does AWS Amplify differ from most backend as a service offerings? Which features does AWS Amplify support? Still no changes in leaders board. AWS Amplify doesn't support continuous deployment. Is it true or false?
By the way, I saw that for Kahoot registered 95 people, but we get only 70 or 75 answers or 73. Somebody give up? Okay.
And we are ready to start a new bunch of questions from Ivan. What is the disadvantage of starter kit solution? Difficult to update. How can we get reusable components?
Control C, Control V.
I see that some people has divided into groups, and I have a question. How are you going to divide the price?
First day I drive electric scooter, then other. Something like that. They will share. They will sell. Something like a business plan. Okay.
Seems like it is an easy question. Almost no changes. Micro frontends bring the benefit of using a single common framework for all apps. What patterns other than micro frontends can be useful to get reusable across apps?
You know, questions become longer and longer. And it becomes read to harder and harder.
Still no changes.
Yeah.
And the last bunch of questions, right? From Viktor.
How
so
many
it's
questions
your
do we
last
still have?
chance
5?
to change the leaders board. What is CI? No changes.
Yeah, but
What is the branching strategy in the picture? Haha.
did you see that Juraev is very closely to Rustam? Very, very. Juraev 00.
What is lead time? A small change.
Marina, why you don't read this question? How to spell the second word?
IAC. Can unit test connect to file system? I think it's very easy question, no?
From your perspective, what's the correct answer?
Sounds like a very easy.
So what the correct answer? Is it true or false?
Unit testing is a part of.
Finish
So,
line.
The last question. Guys, the last question.
Okay.
Do you like our conference?
Yeah, it's very, very hard question. What do you think? What do you think, guys? Yeah, okay.
You still have a time to answer.
Yeah. 3, 2, 1, 0. Oh, okay. So 3%. Most of the okay, nice.
Now we can see your names, right?
Okay. So third, Kate. Second, Juraev. And the winner, Rustam, woo!
So, Kate S. Are you here? Congratulate you with the winning of the 3rd place. You were very close to the first one, but some memorable, thank you. Mr. Jurayev 2000.
No, it's called
Durable. And also, I would add that, what's your name? Avazbek has won also a special gift from AWS team, 25% of promo code, not percent, dollars, right? $25 to AWS platform product.
Yeah. So, the first, Rustam, where are you? Okay, so Rustam is winner, and give this electro scooter. I will spell in Russian. Will our special partner, the sponsor of this present, Andrei Karpov, developer relationship specialist from PVS Studio. So let's make some noise, guys. Yeah! It's pretty heavy, by the way. Yeah.
It's real.
Okay. So you can take it.
Now it's your pain.
By your own. Okay. So I think that's it.
Yes, I would like to invite our org team and to help us to close this conference. And first of all, we truly happy that it happened, and after pandemic situation, we are truly happy to have this opportunity to see you in offline, and we believe that our events will be more greater, will be more famous.
And bigger.
And bigger, with more prizes as well. And Dima?
Last words, I guess. It should be yours. Word.
Yeah. Maybe. Thank you. Thanks for coming. Thanks for your time, for your answer, for your activity, and I would like you to join all our events, our Telegram chats, and interact with our crew here in Tashkent. Thank you very much, and maybe Zafar would like to add something.
Thank you. Join our community as students. Join our community as mentors. Join us as employees. See you next time.
All crew, please come to the stage who help to organize this conference. I see a lot of...
And speakers too.
Yeah, I would like to ask all the volunteers, all the speakers, and everyone who helped to bring the things that we've used here to set up the, you know what to set up, right? Sergey, so come on here.
Seryoja, join us.
And speakers for sure, yeah. Everyone. Also, before you leave, guys, please make sure that you don't forget anything in the audience.
Your stuff.
Yeah, make sure that you you have your jacket so that you don't get cold. And don't forget your cups and any other things that you may leave. Well, this is not a REST. No. Я вот это вот искал вообще-то. Погодите, я программист.
Вот я же сказал, мы еще проконтролируем. Погодите.